150 million years ago, a predator more fearsome than Tyrannosaurus rex stalked the Earth. Meet Allosaurus, the apex carnivore that dominated the Jurassic landscape. This formidable hunter, with its razor-sharp teeth and powerful jaws, revolutionizes our understanding of prehistoric life. From its unique hunting strategies to its surprising intelligence, Allosaurus challenges everything we thought we knew about dinosaurs. As we uncover new fossils and apply cutting-edge scientific techniques, the secrets of this ancient killer are finally coming to light. How did Allosaurus evolve? What made it such a successful predator? And why did it ultimately vanish from the planet? Join us as we piece together the puzzle of this extraordinary creature, rewriting the story of life on Earth and uncovering clues about our own past and future. Allosaurus was a fearsome predator that roamed the Earth during the late Jurassic period, approximately 150 million years ago. This massive carnivorous dinosaur stood up to 10 feet tall at the hip and reached lengths of up to 30 feet, making it one of the largest predators of its time. With its powerful jaws lined with sharp, serrated teeth, Allosaurus was well equipped to hunt and devour other large dinosaurs. The name Allosaurus means different lizard, referring to its unique vertebrae, which were concave on the sides and lightened by air sacs. This feature, along with its strong legs and long tail for balance, made Allosaurus an agile and efficient hunter. Fossil evidence suggests that Allosaurus may have hunted in packs, allowing them to take down even larger prey, such as long-necked sauropods. Allosaurus fossils have been found primarily in North America, particularly in the Morrison Formation, which spans several western states. However, remains have also been discovered in Europe and Africa, indicating a wide distribution of this species. The abundance of Allosaurus fossils has made it one of the best-studied theropod dinosaurs, providing paleontologists with valuable insights into the behavior and biology of these ancient predators. Despite its fearsome reputation, Allosaurus faced its own challenges for survival. Competition with other large predators and environmental changes likely contributed to its eventual extinction. Today, Allosaurus continues to captivate our imagination as one of the iconic predators of the dinosaur era, helping us piece together the complex ecosystems of the ancient world. Allosaurus roamed the Earth during the late Jurassic period, approximately 150 million to 155 million years ago. This fearsome predator was one of the apex carnivores of its time, dominating the landscape alongside other large dinosaurs. During this era, the world was warmer and more humid than it is today, with no polar ice caps. The continents were still in the process of breaking apart from the supercontinent Pangaea. Allosaurus fossils have been found primarily in North America, particularly in the Morrison Formation, which stretches across several western states. Allosaurus shared its environment with other well-known dinosaurs, such as Stegosaurus, Diplodocus, and Brachiosaurus. It was a key player in the ecosystems of the time, likely preying on a variety of herbivorous dinosaurs and possibly engaging in competition with other large predators. The reign of Allosaurus came to an end as the Jurassic period transitioned into the Cretaceous about 145 million years ago. By this time, new predators were evolving, setting the stage for the next chapter in dinosaur evolution. Allosaurus, one of the most fearsome predators of its time, dominated the landscape during the late Jurassic period. This epoch in Earth's history spanned from about 160 million to 145 million years ago. Allosaurus fossils have been found in rock layers dating back to approximately 150 million years before our present day. During this era, the world was vastly different from what we see today. The climate was generally warmer and more humid, with no polar ice caps. Lush forests and ferns covered much of the land, providing ample vegetation for the herbivorous dinosaurs that Allosaurus hunted. The continents were still joined as part of the supercontinent Pangaea, though it had begun to break apart. Allosaurus shared its environment with other iconic dinosaurs like Stegosaurus, Brachiosaurus, and Diplodocus. As a top predator, it played a crucial role in the ecosystem, helping to control populations of herbivorous dinosaurs and contributing to the overall balance of life in the Jurassic world. The reign of Allosaurus came to an end as the Jurassic period transitioned into the Cretaceous about 145 million years ago. By this time, new predators were evolving, setting the stage for the next chapter in Earth's prehistoric saga. Allosaurus roamed the Earth during the late Jurassic period, approximately 150 million to 145 million years ago. This formidable predator was one of the apex carnivores of its time, dominating the landscape alongside other iconic dinosaurs. Fossil evidence shows that Allosaurus thrived in what is now North America, with numerous specimens discovered in the Morrison Formation. This geological layer spans across several western states in the United States, providing a wealth of information about the ecosystem Allosaurus inhabited. As a large theropod dinosaur, Allosaurus played a crucial role in the Jurassic food chain. It likely preyed upon a variety of herbivorous dinosaurs, including long-necked sauropods and armored stegosaurs. The presence of Allosaurus fossils gives scientists valuable insights into the diversity and complexity of life during this ancient period of Earth's history. Understanding the time frame in which Allosaurus existed helps paleontologists piece together the evolutionary history of theropod dinosaurs and their relationships to modern birds, which are considered living descendants of certain theropod lineages. The name Allosaurus comes from ancient Greek and translates to different lizard. This fearsome predator earned its name due to its unique vertebrae, which were distinct from other dinosaurs known at the time of its discovery. Allosaurus was one of the largest carnivorous dinosaurs of the late Jurassic period, roaming the Earth approximately 150 million years ago. Allosaurus was a formidable hunter, reaching lengths of up to 30 feet and weighing as much as 2 tons. Its powerful jaws were lined with sharp, serrated teeth, perfect for tearing into the flesh of its prey. This apex predator likely hunted in packs, allowing it to take down even larger dinosaurs, such as the long-necked sauropods. Fossil evidence suggests that Allosaurus was widespread across North America and Europe during its time. Its reign as one of the top predators lasted for millions of years, making it a crucial part of the Jurassic ecosystem. The study of Allosaurus continues to provide valuable insights into the biology and behavior of large carnivorous dinosaurs. The first Allosaurus fossils were discovered in the late 19th century during the famous Bone Wars, a period of intense fossil hunting and rivalry between paleontologists Othniel Charles Marsh and Edward Drinker Cope. Marsh was the first to describe and name Allosaurus in 1877 based on fragments found in Colorado. However, the most significant early Allosaurus discovery came in 1879 when workers at Como Bluff, Wyoming, uncovered a nearly complete skeleton. This specimen was initially misidentified and attributed to other genera before being correctly recognized as Allosaurus. The Como Bluff site, part of the Morrison Formation, proved to be a treasure trove of Jurassic fossils, yielding numerous Allosaurus remains along with other dinosaur species. These discoveries greatly expanded our understanding of Allosaurus and its place in the Jurassic ecosystem. Since these initial finds, Allosaurus fossils have been unearthed across western North America and even in Europe, cementing its status as one of the most well-known and studied large carnivorous dinosaurs from the Jurassic period. Allosaurus was first scientifically described in 1877 by paleontologist Othniel Charles Marsh. This significant discovery came during the so-called Bone Wars, a period of intense fossil hunting and rivalry between Marsh and his contemporary Edward Drinker Cope. Marsh based his description on fragmentary remains found in Colorado, which included vertebrae and a few other bones. He initially named the species Allosaurus fragilis, meaning different fragile lizard, due to its unique vertebral features and the delicate nature of the fossils. The discovery of Allosaurus marked an important milestone in our understanding of large carnivorous dinosaurs from the late Jurassic period. It helped paleontologists begin to piece together the diversity of theropod dinosaurs that existed alongside other well-known species like Stegosaurus and Diplodocus. Since its initial description, numerous additional Allosaurus specimens have been unearthed, providing scientists with a much more complete picture of this formidable predator. These findings have allowed researchers to refine their knowledge of Allosaurus anatomy, behavior, and its place in the Jurassic ecosystem. Paleontologists have identified several species of Allosaurus, the fearsome predator that roamed North America during the late Jurassic period. The most well-known and widely accepted species is Allosaurus fragilis, which was first discovered in the rich fossil beds of the Morrison Formation. This formation stretches across several western states in the United States and has yielded numerous Allosaurus specimens. Beyond Allosaurus fragilis, researchers have proposed and debated the existence of additional species. Some paleontologists recognize Allosaurus europaeus based on fossils found in Portugal, suggesting that these theropod dinosaurs might have had a wider range than initially thought. Another proposed species is Allosaurus gimmedsani, named after paleontologist James Madsen, which some scientists argue is distinct from Allosaurus fragilis based on subtle anatomical differences. However, the exact number of valid Allosaurus species remains a topic of ongoing scientific discussion. Some proposed species are considered dubious or are still under review by the paleontological community. The process of identifying and confirming new species is complex, requiring detailed analysis of fossil remains and comparison with existing specimens. As research continues and new fossils are unearthed, our understanding of Allosaurus diversity may evolve. The study of these ancient predators provides valuable insights into the ecosystems of the late Jurassic and the evolution of theropod dinosaurs. Allosaurus stands out among theropod dinosaurs for several intriguing features. This large predator, which roamed North America during the late Jurassic period about 150 million years ago, possessed a distinctive skull structure that set it apart from its relatives. The most notable characteristic of Allosaurus was its unusually weak bite force compared to its size. Unlike other large theropods, such as Tyrannosaurus rex, Allosaurus had a bite more suited for slashing than crushing. This unique adaptation was complemented by sharp, serrated teeth and strong neck muscles, suggesting a different hunting strategy. Paleontologists believe Allosaurus may have used its upper jaw like an axe, swinging its head downward to inflict deep, bleeding wounds on its prey. Another distinguishing feature of Allosaurus was its trio of horns, 2 small ridges above its eyes and 1 on the nose. While not as prominent as the horns of later theropods like Carnotaurus, these structures likely played a role in visual display or species recognition. Additionally, Allosaurus possessed unusually long arms for a large theropod, equipped with 3 clawed fingers on each hand, which it could have used effectively in hunting and feeding. The discovery of multiple Allosaurus specimens at sites like the Cleveland Lloyd Dinosaur Quarry has provided valuable insights into their behavior. Evidence suggests these predators may have hunted in packs, a social behavior that would have allowed them to take down much larger prey. This combination of unique physical adaptations and potential social hunting strategies made Allosaurus a formidable and distinctive predator in the Jurassic ecosystem. Allosaurus was a formidable predator that roamed the Earth during the late Jurassic period, approximately 150 million years ago. This fearsome carnivore belongs to the theropod group of dinosaurs, which includes all the meat-eating dinosaurs from the smallest Compsognathus to the mighty Tyrannosaurus rex. Within the theropod group, Allosaurus is classified as part of the Carnosaur branch. Carnosaurs were large, predatory dinosaurs that were the dominant hunters of their time before the rise of the even larger tyrannosaurs. Allosaurus shared this branch with other powerful hunters like Carcharodontosaurus and Giganotosaurus. The Allosaurus lineage represents an important evolutionary step in theropod development. Its body plan, with strong legs, a long tail for balance, and powerful jaws lined with sharp teeth, became a successful template for later large predators. This design allowed Allosaurus to be an efficient hunter, capable of taking down prey much larger than itself. Fossil evidence suggests that Allosaurus was widespread, with remains found in North America, Europe, and Africa. This distribution indicates that Allosaurus and its close relatives were highly successful predators, occupying the apex predator niche across multiple continents during the Jurassic period. Allosaurus was one of the most fearsome predators of the late Jurassic period, roaming the Earth around 150 million years ago. This formidable carnivore stood at an impressive height of about 15 feet from head to tail, with its body measuring roughly 30 feet in length. To put this into perspective, an Allosaurus was about as tall as a modern-day giraffe, but significantly longer. The average weight of an adult Allosaurus was approximately 2 tons, making it a heavyweight among predatory dinosaurs of its time. However, it was not as massive as some of its later relatives, such as Tyrannosaurus rex, which appeared much later in the fossil record. Allosaurus possessed a large skull, measuring up to 3 feet in length, equipped with dozens of sharp, serrated teeth. These teeth, combined with powerful jaw muscles, allowed Allosaurus to be an efficient hunter, capable of taking down large prey. Its arms, while shorter than its legs, were still relatively long for a theropod dinosaur and ended in 3 clawed fingers, useful for grasping and tearing flesh. Despite its impressive size, Allosaurus was built for speed and agility. Its strong hind legs and long counterbalancing tail suggest it was a swift runner, able to chase down its prey across the Jurassic landscapes. This combination of size, strength, and agility made Allosaurus a top predator in its ecosystem, leaving a lasting impression in the fossil record and our understanding of dinosaur evolution. Allosaurus, a fearsome predator from the late Jurassic period, was a massive creature that dominated the landscape. These powerful theropod dinosaurs typically weighed between 2 and 3 metric tons when fully grown. To put this into perspective, an adult Allosaurus was about as heavy as a modern-day hippopotamus or a large car. The weight of an Allosaurus could vary depending on factors such as age, sex, and individual differences. Some exceptionally large specimens might have reached weights of up to 4 metric tons. This considerable mass was supported by strong, muscular legs and a robust skeleton, allowing the Allosaurus to move with surprising agility for its size. Despite their impressive weight, Allosaurus was not the heaviest predator of its time. Some of its contemporaries, like the enormous Saurophaganax, could grow even larger. However, the weight of an Allosaurus was perfectly suited to its role as an apex predator, providing the strength and power needed to take down large prey while maintaining the speed and maneuverability required for successful hunting. Allosaurus, a fearsome predator from the late Jurassic period, stood at an impressive height. At the hip, this powerful theropod dinosaur typically measured between 8 and 10 feet tall. This considerable stature allowed Allosaurus to tower over many of its contemporaries, giving it a significant advantage in hunting and intimidation. To put this height into perspective, imagine an Allosaurus standing next to a modern-day giraffe. While the giraffe would still be taller overall, the dinosaur's hip height would reach about halfway up the giraffe's long neck. This comparison helps illustrate the imposing presence Allosaurus must have had in its ancient ecosystem. The height of Allosaurus contributed to its success as an apex predator. Its elevated hip position provided a high vantage point, allowing it to survey its surroundings and spot potential prey from a distance. Additionally, this height, combined with its powerful leg muscles, enabled Allosaurus to take long strides and move swiftly across the Jurassic landscape in pursuit of its quarry. Allosaurus was a fearsome predator that roamed the Earth during the late Jurassic period, approximately 150 million years ago. This large theropod dinosaur was one of the apex predators of its time, striking fear into herbivores across the landscape. From snout to tail, Allosaurus measured an impressive 30 to 35 feet in length. This made it one of the largest carnivorous dinosaurs of its era, dwarfing many of its potential prey items. Its size allowed it to tackle even some of the larger herbivorous dinosaurs that shared its environment. The skull of Allosaurus alone was up to 3 feet long, filled with sharp, serrated teeth that were perfectly adapted for slicing through flesh. Its powerful jaws and robust build made it a formidable hunter, capable of bringing down large prey with devastating efficiency. Despite its imposing size, Allosaurus was built for speed and agility. Its long, muscular legs and relatively lightweight frame allowed it to move quickly across the Jurassic landscape, chasing down prey or patrolling its territory. This combination of size, strength, and speed made Allosaurus one of the most successful predators of its time. Allosaurus and Tyrannosaurus rex were both large carnivorous dinosaurs, but they differed significantly in size. Allosaurus, which lived during the late Jurassic period about 150 million years ago, was notably smaller than its more famous relative. A typical Allosaurus reached lengths of around 30 to 35 feet and stood about 15 feet tall at the hip. It weighed approximately 2 tons, making it a formidable predator for its time. Tyrannosaurus rex, however, was truly massive in comparison. Living much later during the late Cretaceous period, about 66 million years ago, Tyrannosaurus rex grew to lengths of 40 to 45 feet and could stand 20 feet tall at the hip. The weight difference was even more dramatic. While Allosaurus tipped the scales at about 2 tons, Tyrannosaurus rex could weigh up to 9 tons, more than 4 times as heavy. This enormous size difference reflects the different ecological niches these dinosaurs occupied and the evolutionary changes that occurred over the millions of years separating them. Despite being smaller, Allosaurus was still one of the apex predators of its time, with powerful jaws and sharp teeth adapted for hunting large prey. Tyrannosaurus rex, with its even more robust build and incredibly powerful bite force, represented the pinnacle of theropod evolution, dominating the landscape in the final days of the dinosaurs. Allosaurus, a fearsome predator of the late Jurassic period, was renowned for its large, powerful skull equipped with sharp, serrated teeth. This carnivorous dinosaur's most distinctive physical feature was undoubtedly its skull, which measured up to 3 feet in length and was adorned with ridges above the eyes and nasal cavities. These ridges not only gave Allosaurus a menacing appearance, but also served to strengthen its skull structure. The jaws of Allosaurus were particularly noteworthy, featuring a unique double-hinged design that allowed for an exceptionally wide gape. This adaptation enabled the dinosaur to open its mouth to an impressive 90-degree angle, making it highly effective at capturing and consuming large prey. The teeth of Allosaurus were equally remarkable, curved and blade-like, perfectly suited for slicing through flesh and bone. Another distinctive aspect of the Allosaurus skull was its relatively light construction. Despite its imposing size, the skull was built with numerous openings and air-filled chambers, reducing its overall weight while maintaining structural integrity. This design allowed Allosaurus to wield its powerful jaws with greater speed and precision, making it a formidable hunter in the prehistoric landscape. The combination of these skull features, the prominent ridges, the double-hinged jaw mechanism, the razor-sharp teeth, and the lightweight yet strong construction, made the skull of Allosaurus its most distinctive and recognizable physical characteristic. These adaptations paint a picture of a highly specialized predator, perfectly evolved for its role as one of the apex carnivores of its time. Allosaurus, the fearsome predator that roamed North America during the late Jurassic period, had 3 fingers on each hand. These digits were not just for show, but were highly specialized hunting tools. Each finger was equipped with a large, curved claw that could grow up to 6 inches in length. The 3-fingered hand of Allosaurus was an important part of its predatory arsenal. While its powerful jaws and sharp teeth were its primary weapons, the clawed hands played a crucial role in grasping and manipulating prey. This adaptation allowed Allosaurus to be an efficient and versatile hunter, capable of taking down a variety of dinosaur species. Interestingly, the three-fingered hand of Allosaurus represents an intermediate stage in theropod dinosaur evolution. Earlier carnivorous dinosaurs often had 5 fingers, while later theropods, including the famous Tyrannosaurus rex, evolved to have just 2 functional fingers. This reduction in digit number is a fascinating example of evolutionary specialization in dinosaur limbs. The structure of Allosaurus hands provides valuable insights into the behavior and lifestyle of this ancient predator. By studying these fossilized remains, paleontologists can piece together a more complete picture of how Allosaurus lived and hunted in its prehistoric world. Allosaurus, a fearsome predator from the late Jurassic period, possessed a skull that set it apart from other large carnivorous dinosaurs. The most striking feature was its distinctive array of sharp, blade-like teeth, perfectly adapted for slicing through the flesh of its prey. These teeth were regularly shed and replaced, ensuring the Allosaurus always had a mouthful of razor-sharp weapons at its disposal. The skull of Allosaurus was also remarkably light and flexible, thanks to a series of air-filled chambers and openings. This unique structure allowed the dinosaur to deliver powerful, precise bites while maintaining the agility needed to chase down its victims. The lightweight design of its skull contrasted with the more robust, bone-crushing jaws of some of its contemporaries and later relatives like Tyrannosaurus rex. Another notable feature was the pair of ridges that ran along the top of the Allosaurus skull, from the nose to above the eyes. These ridges not only gave the dinosaur a distinctive appearance, but also might have played a role in visual communication with other members of its species. Some paleontologists suggest these ridges could have been brightly colored, potentially serving as a display feature during mating rituals or territorial disputes. The eyes of Allosaurus were positioned to provide excellent binocular vision, a trait common in predators. This adaptation, combined with its flexible skull and sharp teeth, made Allosaurus a highly efficient hunter, capable of taking down prey much larger than itself. The unique skull structure of Allosaurus offers a fascinating glimpse into the diverse adaptations that evolved among dinosaurs, showcasing the intricate relationship between form and function in prehistoric life. Allosaurus, one of the most fearsome predators of the late Jurassic period, possessed a formidable array of teeth. This carnivorous dinosaur typically had between 70 and 80 teeth in its powerful jaws. These teeth were not uniform in size or shape, but rather varied to serve different functions. The front teeth of Allosaurus were designed for gripping and puncturing prey, while the teeth further back in its mouth were better suited for slicing through flesh. Each tooth was curved and serrated, much like a steak knife, allowing the Allosaurus to efficiently tear through the tough hides of its victims. Interestingly, Allosaurus, like many other dinosaurs and modern reptiles, had the ability to continuously replace its teeth throughout its lifetime. This meant that as teeth wore down or were lost during feeding, new ones would grow to take their place. This constant tooth replacement ensured that Allosaurus always maintained a full set of sharp, deadly teeth ready for its next hunt. The impressive dental arsenal of Allosaurus, combined with its large size and powerful build, made it one of the apex predators of its time, capable of taking down even the largest herbivorous dinosaurs that shared its environment. Allosaurus, a fearsome predator from the late Jurassic period, possessed an array of teeth that were uniquely suited for its carnivorous lifestyle. These teeth were sharp, curved, and serrated, resembling deadly blades that could easily slice through the flesh of its prey. What made them particularly special was their ability to be continuously replaced throughout the dinosaur's lifetime. Unlike mammals, which have a limited set of adult teeth, Allosaurus had a constant supply of replacement teeth waiting in the wings. As one tooth wore down or was damaged, another would emerge to take its place. This continuous cycle ensured that Allosaurus always had a mouthful of razor-sharp teeth ready for hunting and feeding. The shape of Allosaurus' teeth was also noteworthy. They were laterally compressed, meaning they were flattened from side to side. This design allowed them to cut through meat with exceptional efficiency, much like a steak knife. The serrated edges of the teeth further enhanced their cutting power, making it easier for Allosaurus to tear through the tough hides of its prey. Fossil evidence suggests that Allosaurus could have up to 80 teeth in its jaws at any given time. This abundance of teeth, combined with their unique shape and replacement system, made Allosaurus a highly effective predator in the prehistoric ecosystems it inhabited. Allosaurus, a fearsome predator of the late Jurassic period, likely had a skin covering similar to many other theropod dinosaurs. Based on fossil evidence and comparisons with modern reptiles, scientists believe Allosaurus had scaly skin rather than feathers. This skin was probably tough and leathery, providing protection against injury and helping to regulate body temperature. The scales on Allosaurus would have varied in size and texture across different parts of its body. Larger, thicker scales might have covered areas that needed more protection, such as its back and sides, while smaller, more flexible scales could have been present on areas that required greater mobility, like the neck and legs. Although Allosaurus lacked feathers, its skin was not a simple, uniform covering. Fossil impressions suggest that some theropods had intricate patterns and textures on their skin, which could have served for camouflage or display. It is possible that Allosaurus had similar features, with its skin showing a range of colors and patterns that helped it blend into its environment or communicate with other members of its species. The Allosaurus, a fearsome predator of the late Jurassic period, possessed a skull that was a marvel of evolutionary engineering. This carnivorous dinosaur's head was built to deliver powerful bites while also withstanding the forces generated by its prey's struggles. The secret to its strength lay in the skull's unique design and composition. The Allosaurus skull featured several key adaptations that enhanced its durability. Its bones were reinforced with internal struts and ridges, which provided additional support without significantly increasing weight. This internal structure allowed the skull to distribute stress more evenly, preventing fractures during forceful bites or impacts. Another crucial feature was the skull's kinetic design. Unlike the rigid skulls of many other dinosaurs, the Allosaurus had a slightly flexible upper jaw. This flexibility allowed for some movement between skull bones, which helped absorb and dissipate forces that might otherwise cause damage. Additionally, the skull bones were connected by strong but elastic ligaments, further enhancing its ability to withstand stress. The shape of the Allosaurus skull also played a role in its strength. Its long, low profile and streamlined shape helped reduce air resistance during movement and distributed forces more efficiently throughout the structure. This design, combined with powerful jaw muscles and sharp teeth, made the Allosaurus an incredibly effective predator, capable of tackling large prey while minimizing the risk of injury to itself. Allosaurus, the formidable predator of the late Jurassic period, possessed a remarkable adaptation in its neck vertebrae that set it apart from other dinosaurs of its time. This carnivorous theropod had specialized joints in its neck that allowed for increased flexibility and precision in its head movements. The unique feature of the Allosaurus neck was a ball and socket joint between the skull and the first neck vertebra. This joint, known as the atlanto-occipital joint, provided a greater range of motion compared to other large theropods. It allowed Allosaurus to move its head more freely from side to side and up and down, enhancing its ability to track and capture prey. Additionally, the subsequent neck vertebrae of Allosaurus had elongated neural spines. These spines served as attachment points for powerful neck muscles, further contributing to the dinosaur's neck strength and mobility. This combination of flexible joints and strong musculature gave Allosaurus a distinct advantage in hunting and feeding behaviors. The enhanced neck mobility of Allosaurus likely played a crucial role in its hunting strategy. It could strike with greater accuracy and speed, making it a more efficient predator in the Jurassic ecosystem. This adaptation highlights the diverse evolutionary paths taken by different dinosaur species to become successful in their respective niches. Allosaurus, a fearsome predator of the late Jurassic period, possessed legs that were masterfully adapted for hunting. These powerful limbs were built for speed and agility, allowing the carnivore to chase down its prey with remarkable efficiency. The leg bones of Allosaurus were hollow yet strong, reducing weight while maintaining structural integrity. This design enabled the dinosaur to move swiftly across varied terrain. The muscular thighs and lower legs of Allosaurus provided the strength needed for explosive bursts of speed, crucial for ambushing or pursuing potential meals. Its feet were equipped with sharp claws, not only aiding in traction during high-speed chases, but also serving as formidable weapons for grappling with prey. The arrangement of bones in the Allosaurus foot allowed for a spring-like action, further enhancing its running capabilities. Interestingly, the legs of Allosaurus were slightly shorter in proportion to its body than those of some other large theropods. This lower center of gravity likely improved its stability and maneuverability, especially when dealing with struggling prey. The combination of strength, speed, and stability made the legs of Allosaurus a perfect complement to its other hunting adaptations, such as its powerful jaws and sharp teeth. Allosaurus, a fearsome predator of the late Jurassic period, possessed distinctive bony ridges above its eyes. These prominent features served multiple purposes, enhancing both the physical capabilities and the appearance of this formidable dinosaur. The primary function of these ridges was to protect the eyes of Allosaurus during hunting and combat. When pursuing prey or engaging in territorial disputes with other predators, the ridges acted as a natural shield, deflecting blows and preventing injury to the vulnerable eye area. This adaptation was crucial for a large carnivore that relied heavily on its vision for hunting and survival. Additionally, the ridges likely played a role in thermoregulation. Blood vessels running through these bony structures could help regulate the temperature of the brain by allowing heat to dissipate more efficiently. This feature would have been particularly useful for an active predator in the warm Jurassic climate. Furthermore, these prominent ridges may have served as display features for intraspecies communication. They could have been used to signal age, health, or dominance to potential mates or rivals, much like the colorful feathers or enlarged features seen in many modern birds, the descendants of dinosaurs. The imposing appearance created by these ridges would have contributed to the overall menacing look of Allosaurus, potentially intimidating prey and competing predators alike. Allosaurus and Tyrannosaurus rex, two fearsome predators from different eras of the Mesozoic, had notably different forelimbs. Allosaurus, which lived during the late Jurassic period about 150 million years ago, possessed longer, more robust arms with 3 fingers on each hand. These arms were functional and likely played a role in hunting and manipulating prey. In contrast, Tyrannosaurus rex, which roamed the Earth during the late Cretaceous period about 66 million years ago, had notoriously small arms in proportion to its massive body. The arms of Tyrannosaurus were much shorter and less muscular than those of Allosaurus, with only 2 fingers on each hand. This reduction in arm size and functionality occurred over millions of years of evolution. The differences in arm structure between these two theropod dinosaurs reflect their distinct hunting strategies and evolutionary paths. Allosaurus likely used its arms to grasp and hold on to prey, working in conjunction with its powerful jaws. Tyrannosaurus, on the other hand, relied primarily on its enormous skull and bone-crushing teeth to subdue prey, with its arms playing a minimal role in hunting. These contrasting anatomical features highlight the diverse adaptations that evolved among theropod dinosaurs over time, showcasing the complex and fascinating evolutionary history of these prehistoric predators. Allosaurus, the fearsome predator of the late Jurassic period, possessed several adaptations that enhanced its binocular vision, making it a highly effective hunter. The skull of Allosaurus was designed with forward-facing eye sockets, allowing for significant overlap in the visual fields of both eyes. This arrangement provided the dinosaur with excellent depth perception, crucial for judging distances when pursuing prey. The eyes of Allosaurus were also relatively large in proportion to its skull, suggesting they played a vital role in its hunting strategy. These oversized eyes would have captured more light, potentially improving vision in low-light conditions such as dawn and dusk. This adaptation might have given Allosaurus an advantage over its prey, allowing it to hunt during times when other predators were less active. Furthermore, the shape of the Allosaurus skull included pronounced ridges above the eyes. These ridges likely served to protect the eyes during hunting and combat, but they may have also helped to shade the eyes from harsh sunlight, much like the brow ridges in modern predatory birds. This feature would have further enhanced the dinosaur's visual acuity, allowing it to spot potential prey from considerable distances. The combination of these adaptations resulted in a highly developed visual system that complemented the other predatory features of Allosaurus, such as its sharp teeth and powerful limbs. This sophisticated binocular vision would have been a key factor in the success of Allosaurus as one of the apex predators of its time, enabling it to effectively track, pursue, and capture its prey in the diverse ecosystems of the late Jurassic world. The tail of Allosaurus served several crucial functions for this fearsome predator of the late Jurassic period. As a counterbalance to its massive skull, the muscular tail helped Allosaurus maintain its center of gravity while moving and hunting. This balance was essential for the theropod's agility, allowing it to make quick turns and sudden movements when chasing prey. Moreover, the powerful tail muscles of Allosaurus played a vital role in locomotion. By swinging from side to side, the tail generated additional force that propelled the dinosaur forward, increasing its speed and efficiency during both walking and running. This tail-driven momentum was particularly useful when Allosaurus needed to accelerate quickly to catch its prey or escape from larger predators. Scientists also believe that the tail of Allosaurus might have been used as a weapon in certain situations. When facing rival Allosaurus or other large predators, it could have swung its tail forcefully to deliver powerful blows, potentially deterring attackers or competing for territory and resources. Lastly, the tail likely played a role in communication and display behaviors. Like many modern animals, Allosaurus might have used tail postures and movements to signal aggression, submission, or even as part of courtship rituals, though the specifics of such behaviors remain speculative based on our current understanding of dinosaur behavior. Allosaurus was a formidable predator that dominated the late Jurassic period, about 150 million years ago. Its success as a hunter stemmed from several key adaptations. The name Allosaurus means different lizard, and this carnivore certainly stood out among its contemporaries. One of the most striking features of Allosaurus was its skull. It had a large, powerful jaw lined with sharp, serrated teeth designed for slicing through flesh. The skull was relatively light and flexible, allowing it to withstand the stresses of biting and tearing at prey. This combination of strength and flexibility made Allosaurus particularly adept at tackling large, armored herbivores. The body of Allosaurus was built for speed and agility. It stood on two strong hind legs, with a long, counterbalancing tail that helped it maintain balance while running and turning. Its forearms, though short, were equipped with sharp claws that could grasp and hold onto prey. This body structure allowed Allosaurus to chase down its victims and deliver powerful, precise attacks. Another advantage Allosaurus had was its size. Growing up to 30 feet long and weighing over 2 tons, it was large enough to take on substantial prey, but still agile enough to outmaneuver many of its potential meals. This balance of power and speed made Allosaurus a versatile and successful predator, capable of hunting a wide range of prey in the diverse ecosystems of the late Jurassic period. Allosaurus, a formidable predator of the late Jurassic period, possessed sensory abilities that were well suited to its role as an apex carnivore. Like many large theropods, Allosaurus had relatively large eyes, suggesting good visual acuity. This keen eyesight would have been crucial for spotting prey and navigating its environment. The olfactory bulbs of Allosaurus were also well developed, indicating a strong sense of smell. This olfactory prowess was likely on par with, or possibly superior to, that of its contemporary theropods. A keen sense of smell would have aided Allosaurus in tracking prey, detecting carrion, and possibly even in social interactions with other members of its species. Interestingly, Allosaurus had unusually large sinuses in its skull, which some paleontologists believe may have enhanced its sense of hearing. This adaptation could have given Allosaurus an edge in detecting the movements of prey or the approach of rival predators. However, the exact auditory capabilities of Allosaurus compared to other theropods remain a subject of ongoing research and debate. When compared to later theropods like Tyrannosaurus rex, Allosaurus may have relied more heavily on its visual and olfactory senses for hunting, rather than the bone-crushing bite force that characterized some of its successors. This sensory suite, combined with its agility and sharp claws, made Allosaurus a highly effective predator in the diverse ecosystems of the late Jurassic period. Allosaurus, a formidable predator of the late Jurassic period, employed a hunting strategy that combined stealth, power, and precision. This large theropod dinosaur, standing up to 10 meters long, was a skilled ambush predator. It likely stalked its prey, using the cover of vegetation or terrain to approach undetected. The key to Allosaurus's hunting success lay in its powerful jaws and sharp, serrated teeth. Unlike some other large theropods, Allosaurus had a relatively weak bite force. Instead, it used its upper jaw like a hatchet, swinging its head downward to inflict deep, slashing wounds on its prey. This technique, often called the slash and tear method, allowed Allosaurus to take down even large sauropods. Fossil evidence suggests that Allosaurus might have hunted in packs, at least occasionally. This cooperative behavior would have allowed them to tackle larger prey, such as the massive sauropods that shared their environment. By working together, a group of Allosaurus could have surrounded and overwhelmed prey that would have been too dangerous for a single individual to attack. The hunting strategy of Allosaurus was further enhanced by its keen senses, particularly its vision. Large eye sockets indicate that it had excellent eyesight, crucial for spotting prey and coordinating attacks. This combination of stealth, powerful jaws, potential pack hunting, and sharp senses made Allosaurus one of the most successful predators of its time. Allosaurus, the formidable predator of the late Jurassic period, was a swift and agile hunter. While precise speed measurements for extinct animals are challenging to determine, paleontologists have made educated estimates based on fossil evidence and comparisons with modern animals. Current research suggests that Allosaurus could likely reach speeds of up to 25 miles per hour in short bursts. This speed, comparable to that of a modern-day ostrich, would have made Allosaurus one of the fastest large predators of its time. Its long, powerful legs and relatively lightweight build contributed to its impressive agility. However, it is important to note that Allosaurus probably did not maintain such high speeds for extended periods. Like many large predators, it likely relied on ambush tactics and short chases to capture prey. The dinosaur's speed, combined with its sharp claws and serrated teeth, made it a highly effective hunter in the Jurassic landscape. Recent studies of Allosaurus fossils have also revealed interesting details about its hunting behavior. Analysis of its leg bones and muscle attachment sites indicates that Allosaurus had excellent acceleration, allowing it to quickly close the distance between itself and its prey. This burst of speed, rather than sustained running, was likely its primary hunting strategy. Allosaurus, a fearsome predator from the late Jurassic period, primarily hunted large, herbivorous dinosaurs. These powerful carnivores, standing up to 10 meters long, were well equipped to take down substantial prey with their sharp, serrated teeth and strong clawed arms. Evidence suggests that Allosaurus frequently targeted sauropods, the long-necked giants of the Jurassic. However, these cunning hunters likely did not limit themselves to a single type of prey. Fossil records indicate that they also pursued other large herbivores such as Stegosaurus and Camptosaurus. Allosaurus hunting strategies likely involved ambush tactics and pack hunting. By working together, groups of Allosaurus could have taken down even the largest sauropods. This cooperative hunting behavior, similar to that seen in modern wolves, would have made Allosaurus a formidable presence in the Jurassic ecosystem. The varied diet of Allosaurus, encompassing different species of large plant eaters, demonstrates its adaptability and success as an apex predator. This diverse prey selection contributed to the Allosaurus's prominence in the Jurassic food chain, shaping the dynamics of prehistoric ecosystems for millions of years. Allosaurus, a fearsome predator of the late Jurassic period, employed a combination of strength, strategy, and specialized adaptations to tackle the enormous sauropods that shared its environment. Standing up to 30 feet long and weighing over 2 tons, Allosaurus was a formidable hunter, but it still faced significant challenges when targeting the much larger sauropods. The key to Allosaurus's hunting strategy lay in its powerful jaws and sharp, serrated teeth. Unlike some other large theropods, Allosaurus had a relatively weak bite force. Instead, it used its upper jaw like a hatchet, swinging its head downward to inflict deep, slashing wounds. This technique allowed it to cause severe damage to its prey while minimizing the risk of breaking its own teeth on the tough hide of a sauropod. Paleontologists believe Allosaurus might have hunted in packs, though this remains a subject of debate. If true, pack hunting would have given Allosaurus a significant advantage when taking on sauropods. Multiple Allosaurus could have worked together to exhaust and bring down prey many times their size, much like modern wolves hunting large ungulates. Another crucial factor in Allosaurus's success was likely its speed and agility. Despite its size, Allosaurus was built for quick, powerful movements. This allowed it to deliver multiple slashing attacks and retreat quickly, gradually wearing down larger, slower sauropods through blood loss and exhaustion. By targeting vulnerable areas such as the neck, flanks, or legs, Allosaurus could eventually bring down even the largest of prey, showcasing the effectiveness of its hunting adaptations in the prehistoric ecosystem. Allosaurus and Tyrannosaurus rex were formidable predators that lived millions of years apart, each with unique hunting adaptations. Allosaurus, which roamed during the late Jurassic period, possessed several advantages over its later counterpart. One key advantage was Allosaurus's lighter build and greater agility. Its slender, more gracile body allowed for quicker movements and faster running speeds. This agility would have been crucial for chasing down swift prey or maneuvering in dense forests. Allosaurus also had longer, more flexible arms with sharp claws. These powerful limbs could have been used to grasp and manipulate prey, giving Allosaurus an edge in close combat. In contrast, Tyrannosaurus rex had notoriously short arms with limited utility in hunting. The skull of Allosaurus was designed for slicing rather than crushing. Its teeth were blade-like and serrated, ideal for inflicting deep, bleeding wounds. This hunting strategy differed from Tyrannosaurus rex's bone-crushing bite, allowing Allosaurus to potentially take down larger prey through repeated strikes and blood loss. Allosaurus, a fearsome predator of the late Jurassic period, used its arms as powerful weapons during its hunts. Unlike the tiny arms of Tyrannosaurus rex, Allosaurus had relatively long, muscular forelimbs equipped with sharp, curved claws. These arms played a crucial role in its predatory strategy. When pursuing prey, Allosaurus would use its powerful legs to chase down its target. Once within striking distance, it would deploy its arms to grapple and hold onto its victim. The strong muscles in its shoulders and upper arms allowed Allosaurus to exert considerable force, helping it to subdue even large prey. The three-fingered hands of Allosaurus were particularly well suited for gripping. Each finger ended in a sharp, hook-like claw that could dig into the flesh of its prey, preventing escape. This grasping ability, combined with its powerful jaws, made Allosaurus a highly effective predator. Paleontologists believe that Allosaurus might have also used its arms to slash at prey, causing deep wounds with its claws. This tactic would have been especially useful when hunting larger dinosaurs, allowing Allosaurus to inflict damage while staying clear of dangerous defensive weapons like the tail of a Stegosaurus. Allosaurus was a dominant predator in the late Jurassic period, approximately 150 million years ago. This large theropod dinosaur occupied the role of apex predator in its ecosystem, preying on a variety of herbivorous dinosaurs, including sauropods and stegosaurs. Standing up to 30 feet long and weighing over 2 tons, Allosaurus was well equipped for hunting. Its powerful jaws were lined with sharp, serrated teeth designed for slicing through flesh. Fossil evidence suggests that Allosaurus may have hunted in packs, allowing it to take down prey much larger than itself. As a top predator, Allosaurus played a crucial role in maintaining the balance of its ecosystem. By controlling herbivore populations, it prevented overgrazing and helped shape the plant communities of the time. The presence of such a formidable hunter also likely influenced the evolution of defensive features in its prey, such as the plates and spikes of Stegosaurus. Allosaurus fossils have been found alongside those of other predatory dinosaurs, indicating a complex ecosystem with multiple carnivore species. This suggests that Allosaurus competed with other predators for resources, further contributing to the intricate web of interactions that characterized late Jurassic environments. Allosaurus, the fearsome predator of the late Jurassic period, possessed a unique and highly effective jaw mechanism. Unlike many other large carnivorous dinosaurs, Allosaurus had a relatively weak bite force. However, it compensated for this with a specialized jaw structure that allowed it to inflict devastating wounds on its prey. The key to Allosaurus's hunting success lay in its upper jaw and skull. The bones of its upper jaw were loosely connected to the rest of its skull, allowing for a surprising degree of flexibility. When Allosaurus opened its mouth wide, its upper jaw would lift upwards and outwards, effectively increasing the gape of its mouth. This motion exposed rows of sharp, serrated teeth that could slice through flesh with ease. As Allosaurus closed its jaws, it would bring its upper teeth down in a chopping motion, much like an axe. This action, combined with the dinosaur's powerful neck muscles, allowed it to drive its teeth deep into its prey, creating large, gaping wounds. The loose connection of the upper jaw also helped absorb the shock of these powerful bites, preventing damage to the dinosaur's own skull. This efficient killing mechanism made Allosaurus a formidable predator, capable of taking down large prey despite its relatively weak bite force. Its jaw adaptation showcases the diverse hunting strategies that evolved among dinosaurs, highlighting the complex and varied nature of prehistoric ecosystems. Allosaurus, a fearsome predator from the late Jurassic period, possessed a formidable bite force that made it one of the top carnivores of its time. While not the strongest biter among dinosaurs, Allosaurus had a unique hunting strategy that complemented its jaw strength. Studies suggest that Allosaurus had a bite force of around 6,000 newtons, which is comparable to that of a modern-day lion or tiger. This force, while impressive, was actually relatively weak for its size. However, Allosaurus compensated for this with its hunting technique. It likely used its upper jaw like an axe, striking down on its prey with the assistance of powerful neck muscles. In comparison to other prehistoric predators, Allosaurus's bite force was moderate. Tyrannosaurus rex, which lived much later, had a bite force estimated at over 50,000 newtons, making it one of the strongest biters ever known. Another formidable biter was Megalodon, an extinct species of shark with an estimated bite force of over 180,000 newtons. Despite not having the strongest bite, Allosaurus was an effective predator. Its teeth were serrated and sharp, designed for slicing through flesh rather than crushing bone. This, combined with its unique hunting strategy, allowed Allosaurus to dominate its ecosystem for millions of years. The hunting behavior of Allosaurus, a large theropod dinosaur from the late Jurassic period, has been a subject of debate among paleontologists for years. While definitive evidence is limited, recent research suggests that Allosaurus might have engaged in both solitary and group hunting behaviors, depending on the circumstances. Fossil evidence from sites like the Cleveland Lloyd Dinosaur Quarry in Utah has revealed large concentrations of Allosaurus remains alongside those of their potential prey. This has led some scientists to propose that Allosaurus might have hunted in packs, similar to some modern predators. Group hunting could have allowed these carnivores to take down larger prey, such as long-necked sauropods, which would have been challenging for a single Allosaurus to tackle alone. However, other paleontologists argue that the fossil evidence is inconclusive and could be the result of other factors, such as multiple individuals being drawn to the same food source over time. They point out that Allosaurus had features more commonly associated with solitary hunters, such as serrated teeth and powerful jaws suited for delivering killing bites. The truth may lie somewhere in between. Allosaurus might have been an opportunistic predator, hunting alone when pursuing smaller prey, but potentially forming temporary groups when targeting larger, more formidable dinosaurs. This flexible hunting strategy would have made Allosaurus a highly successful predator in the diverse ecosystems of the late Jurassic period. Allosaurus and Tyrannosaurus rex were both fearsome predators, but their hunting styles were quite different. Allosaurus, which lived during the late Jurassic period about 150 million years ago, was likely a pack hunter. Its lighter build and longer arms suggest it was more agile and could grapple with prey. Paleontologists believe Allosaurus might have hunted in groups, taking down large sauropods by overwhelming them with multiple attackers. In contrast, Tyrannosaurus rex, which lived much later during the late Cretaceous period, about 68 million years ago, was likely a solitary hunter. Its massive size, powerful jaws, and keen sense of smell made it a formidable predator on its own. T-Rex had relatively small arms, indicating it relied more on its enormous skull and bone-crushing teeth to dispatch prey. Some scientists suggest it might have been an ambush predator, using its acute senses to locate prey before launching a devastating attack. The skull structure of these two dinosaurs also hints at their different hunting methods. Allosaurus had a more flexible skull that could withstand the stresses of slashing attacks, while T-Rex had a rigid skull built for delivering powerful, bone-shattering bites. This suggests Allosaurus might have used repeated bites to weaken its prey, whereas T-Rex could potentially kill with a single, crushing bite. These differences in hunting styles reflect the distinct evolutionary paths and ecological roles of these two apex predators. While both were successful hunters, they adapted to their specific environments and prey types in unique ways, showcasing the diversity of predatory strategies among large theropod dinosaurs. The Tyrannosaurus rex, or T-Rex, had a significantly more powerful bite than the Allosaurus. This formidable predator from the late Cretaceous period possessed a bite force that dwarfed that of its earlier relative. Studies suggest that the T-Rex could exert a bite force of up to 57,000 newtons, equivalent to the weight of 3 small cars. In contrast, the Allosaurus, which lived during the late Jurassic period, had a much weaker bite. Its jaw strength was estimated to be only about 1/3 to 1/4 that of the T-Rex. The Allosaurus relied more on a slashing and tearing technique, using its upper jaw like a hatchet to inflict wounds on its prey. The T-Rex's powerful bite was made possible by its robust skull structure and thick, conical teeth. These teeth, some measuring up to 8 inches in length, were capable of crushing bone and tearing through tough hide. The immense jaw muscles of the T-Rex, anchored to its large skull, provided the strength needed to deliver such devastating bites. While both dinosaurs were apex predators of their time, the T-Rex evolved to become a bone-crushing powerhouse, capable of taking down large prey with its incredible bite force. This adaptation allowed it to dominate its ecosystem and secure its place as one of the most fearsome predators in Earth's history. Comparing the intelligence of dinosaurs like Allosaurus and Tyrannosaurus rex is a fascinating yet challenging task for paleontologists. Both were apex predators in their respective time periods, with Allosaurus living during the late Jurassic and Tyrannosaurus rex existing in the late Cretaceous. Scientists use brain size relative to body size, known as the encephalization quotient, as one measure of potential intelligence. Allosaurus had a slightly higher encephalization quotient than Tyrannosaurus rex, suggesting it might have been marginally more intelligent. However, this difference is not significant enough to draw definitive conclusions. Both dinosaurs possessed enlarged areas in their brains associated with sensory processing, particularly for vision and smell. This indicates they were well-adapted predators with keen senses. Tyrannosaurus rex had exceptionally large olfactory bulbs, implying a highly developed sense of smell that may have aided in hunting and scavenging. While direct comparisons of intelligence between these extinct species remain speculative, both Allosaurus and Tyrannosaurus rex were likely among the most cognitively advanced dinosaurs of their time. Their predatory lifestyles required problem-solving skills, spatial awareness, and possibly even some level of social behavior, all indicators of relatively high intelligence in the dinosaur world. When comparing the speed of Allosaurus and Tyrannosaurus rex, we enter a realm of scientific debate and educated estimation. Both were formidable predators of their respective eras, but their physical characteristics suggest different locomotion capabilities. Allosaurus, which lived during the late Jurassic period, about 150 million years ago, was likely the faster of the two. Its lighter build, longer legs relative to its body size, and less massive body contributed to greater agility and speed. Scientists estimate that Allosaurus could have reached speeds of up to 30 miles per hour in short bursts. Tyrannosaurus rex, on the other hand, lived much later during the late Cretaceous period, about 66 million years ago. It was significantly larger and heavier than Allosaurus, with proportionally shorter legs and a more massive body. These features suggest that Tyrannosaurus rex was slower, with estimated top speeds ranging from 12 to 18 miles per hour. However, it is crucial to note that speed was not the only factor in these dinosaurs' hunting success. Tyrannosaurus rex compensated for its lower speed with incredible bite force and overall power, making it a formidable predator despite being slower than its earlier counterpart, Allosaurus. Tyrannosaurus rex and Allosaurus were both fearsome predators of their respective eras, but they differed significantly in their arm structure and strength. Allosaurus, which lived during the late Jurassic period about 150 million years ago, had relatively longer and more robust arms compared to Tyrannosaurus rex, which lived much later during the late Cretaceous period, about 68 to 66 million years ago. The arms of Allosaurus were well developed and functional, with 3 clawed fingers on each hand. These arms were strong enough to assist in hunting and grasping prey. In contrast, Tyrannosaurus rex had notoriously small arms in proportion to its massive body. Despite their small size, Tyrannosaurus rex arms were surprisingly muscular, with some studies suggesting they could lift up to 400 pounds. However, the role of Tyrannosaurus rex arms in hunting and feeding remains a subject of debate among paleontologists. Some theories suggest they might have been used for close-quarter grappling with prey or mates, while others propose they were vestigial structures with limited function. Allosaurus, on the other hand, likely used its arms more actively in hunting and feeding behaviors. This comparison highlights the evolutionary changes in theropod dinosaurs over time. While earlier predators like Allosaurus relied more on their arms, later theropods like Tyrannosaurus rex evolved to depend primarily on their massive skulls and powerful bite force for hunting and feeding. The debate over which dinosaur had superior vision, Allosaurus or Tyrannosaurus rex, has intrigued paleontologists for years. Both were apex predators of their respective eras, with keen senses that made them formidable hunters. However, recent studies suggest that Allosaurus might have had the edge when it came to visual acuity. Allosaurus, which lived during the late Jurassic period about 150 million years ago, possessed large eyes relative to its skull size. Its eye sockets were positioned to provide a wide field of view, crucial for scanning its environment for prey or threats. Fossil evidence indicates that Allosaurus had a sclerotic ring, a bony structure that supported the eye, suggesting it had excellent vision in various light conditions. Tyrannosaurus rex, on the other hand, lived much later during the late Cretaceous period, about 68 to 66 million years ago. While it had forward-facing eyes that provided good depth perception, its eyes were proportionally smaller compared to its massive skull. This has led some scientists to speculate that T-Rex might have relied more on its acute sense of smell rather than vision for hunting. The orientation of the eyes in Allosaurus allowed for better peripheral vision, which would have been advantageous for detecting movement in its environment. This, combined with its earlier place in evolutionary history, suggests that Allosaurus might have developed keener eyesight as a primary hunting tool. However, it is important to note that both dinosaurs were highly successful predators, each adapted to its specific environment and prey. Allosaurus and Tyrannosaurus rex were both formidable predators that lived during different periods of the Mesozoic era. Allosaurus roamed the Earth during the late Jurassic period, approximately 150 million years ago. In contrast, Tyrannosaurus rex appeared much later during the late Cretaceous period, about 68 to 66 million years ago. When it comes to individual lifespans, these two dinosaurs showed some differences. Allosaurus is estimated to have lived for about 20 to 28 years. This lifespan allowed it to grow to its full size of about 9 to 12 meters in length and reach its peak hunting capabilities. Tyrannosaurus rex, on the other hand, had a longer lifespan. Studies of T-Rex fossils suggest that these massive predators could live up to 30 years or possibly even longer. This extended lifespan gave T-Rex more time to grow, which partly explains its larger size compared to Allosaurus. T-Rex could reach lengths of up to 12 to 13 meters, towering over its Jurassic predecessor. The difference in lifespans between these two species likely reflects their different evolutionary paths and the specific environmental pressures they faced. The longer lifespan of T-Rex might have been an adaptation that allowed it to become the apex predator of its time, while the shorter-lived Allosaurus was well suited to the competitive ecosystem of the late Jurassic period. Allosaurus and Tyrannosaurus rex were both formidable predators of the Mesozoic era, but their dietary habits differed significantly. Allosaurus, which lived during the late Jurassic period about 150 million years ago, had a more diverse diet compared to its later relative, Tyrannosaurus rex. Fossil evidence suggests that Allosaurus was an opportunistic hunter and scavenger. Its teeth were designed for slicing through flesh, but they were also capable of crushing bone. This adaptability allowed Allosaurus to feed on a wide range of prey, from smaller dinosaurs to large sauropods. Studies of Allosaurus fossils have revealed tooth marks on various dinosaur bones, indicating a broad dietary range. In contrast, Tyrannosaurus rex, which lived during the late Cretaceous period about 66 million years ago, had a more specialized diet. Its massive skull and powerful jaws were built for delivering bone-crushing bites, suggesting a preference for large prey. T-Rex likely focused on hunting and scavenging other large dinosaurs, particularly ceratopsians like Triceratops and hadrosaurs. While both dinosaurs were apex predators, Allosaurus demonstrated greater dietary flexibility. This adaptability may have contributed to its success over a longer evolutionary period, whereas T-Rex's specialized hunting strategy was highly effective but potentially more vulnerable to environmental changes. Allosaurus and Tyrannosaurus rex were formidable predators that ruled different eras and territories in prehistoric North America. Allosaurus roamed the landscape during the late Jurassic period, approximately 150 million years ago. Its hunting grounds stretched across what is now the western United States, with fossils found in states like Colorado, Utah, and Wyoming. These areas were then lush, subtropical environments with abundant prey for the Allosaurus to hunt. Tyrannosaurus rex, on the other hand, appeared much later in the fossil record during the late Cretaceous period, about 68 to 66 million years ago. Its territory was more extensive, covering a large portion of western North America, from Canada down to the southwestern United States. The environment during T. rex's time was more varied, ranging from coastal swamps to inland forests and plains. The differing time periods meant these two predators never crossed paths, but they likely filled similar ecological niches in their respective eras. Allosaurus hunted in a world dominated by long-necked sauropods and other large herbivores, while Tyrannosaurus rex preyed on horned dinosaurs like Triceratops and duck-billed hadrosaurs. These distinct hunting territories and prey species led to differences in hunting strategies and physical adaptations between Allosaurus and Tyrannosaurus rex, shaping their roles as apex predators in their respective prehistoric ecosystems. Allosaurus, a fearsome predator of the late Jurassic period, possessed several attributes that made it a highly effective hunter, potentially even more deadly than its later cousin Tyrannosaurus rex in certain aspects. One key advantage of Allosaurus was its relatively long arms equipped with sharp, curved claws. These powerful forelimbs could grasp and manipulate prey with precision, a feature that Tyrannosaurus rex lacked due to its notoriously short arms. This allowed Allosaurus to potentially subdue larger prey or handle struggling victims more effectively. The skull of Allosaurus was also uniquely adapted for efficient killing. Its jaws were lined with serrated, blade-like teeth and could open extremely wide, allowing it to deliver devastating, slashing bites. This contrasts with the crushing bite of Tyrannosaurus rex, which, while immensely powerful, may have been less versatile in some hunting scenarios. Furthermore, Allosaurus was likely more agile and faster than Tyrannosaurus rex. Its lighter build and longer legs suggest it could pursue prey over longer distances and navigate more varied terrain. This increased mobility could have made Allosaurus a more persistent and adaptable hunter, capable of tackling a wider range of prey in diverse environments. Allosaurus has featured prominently in various dinosaur-themed media, often depicted as a fearsome predator of the Jurassic period. In many portrayals, this large theropod is shown as a powerful hunter, rivaling the more famous Tyrannosaurus rex in its ferocity and predatory skills. One notable appearance of Allosaurus was in the BBC documentary series Walking with Dinosaurs. Here, the dinosaur was presented as the apex predator of its time, showcasing its hunting techniques and social behaviors. This depiction aimed for scientific accuracy, portraying Allosaurus as a pack hunter and scavenger when necessary. In Hollywood productions, Allosaurus has sometimes been cast as a villain, chasing human characters or battling other dinosaurs. The Jurassic World franchise included Allosaurus among its roster of genetically recreated dinosaurs, presenting it as a formidable threat alongside other prehistoric predators. While not as ubiquitous as Tyrannosaurus rex or Velociraptor in popular media, Allosaurus continues to capture the imagination of filmmakers and audiences alike. Its portrayal often emphasizes its role as a dominant carnivore of the Jurassic landscape, contributing to our cultural fascination with prehistoric life. Several renowned museums across the world proudly display Allosaurus skeletons, offering visitors a glimpse into the Jurassic period when these fearsome predators roamed the Earth. The American Museum of Natural History in New York City houses an impressive Allosaurus specimen, allowing guests to marvel at its size and sharp teeth. This institution has been at the forefront of dinosaur research and exhibition for over a century. Moving westward, the Denver Museum of Nature and Science in Colorado boasts a remarkable Allosaurus display. Colorado holds special significance in Allosaurus history, as many fossils of this species have been discovered in the state. The museum's exhibit provides context about the local paleontological findings and the creature's habitat. Crossing the Atlantic, the Natural History Museum in London showcases an Allosaurus skeleton that captivates visitors from around the globe. This specimen helps illustrate the widespread nature of Allosaurus fossils and the international interest in these prehistoric hunters. In Europe, the Museum for Naturkunde in Berlin also features an Allosaurus skeleton, contributing to the scientific understanding and public fascination with these Jurassic predators. These diverse museum exhibits collectively paint a vivid picture of Allosaurus, its physical characteristics, and its place in prehistoric ecosystems. Many popular depictions of Allosaurus, while impressive, often fall short of scientific accuracy. These representations, seen in movies, television shows, and even some museum displays, frequently exaggerate certain features or rely on outdated information. One common misconception is the size of Allosaurus. While it was indeed a large predator, some portrayals inflate its dimensions, making it appear larger than it truly was. In reality, Allosaurus typically reached lengths of about 30 to 35 feet and stood around 10 to 15 feet tall at the hip. Another area where depictions often stray from accuracy is in the posture of Allosaurus. Older representations often show the dinosaur with an upright, tail-dragging stance. However, modern paleontological evidence suggests that Allosaurus, like many other theropod dinosaurs, held its body and tail in a more horizontal position, with the tail extended for balance. The head and jaw structure of Allosaurus are also frequently misrepresented. While it did have a large skull with sharp teeth, some depictions exaggerate the size of its mouth or the length of its teeth. Recent studies have provided a more nuanced understanding of its bite mechanics and hunting behavior, showing that Allosaurus likely used its upper jaw like an axe, slashing at prey rather than relying solely on crushing bites. Allosaurus, one of the most famous predatory dinosaurs from the late Jurassic period, has been a staple in popular media for decades. However, several misconceptions about this fearsome carnivore persist. One common error is the portrayal of Allosaurus as a contemporary of Tyrannosaurus rex. In reality, Allosaurus lived much earlier, roaming the Earth around 150 million years ago, while Tyrannosaurus appeared nearly 80 million years later. Another frequent misrepresentation is the size of Allosaurus. While it was indeed a large predator, it is often exaggerated to rival the size of later theropods like Tyrannosaurus. Allosaurus typically reached lengths of about 30 feet and stood around 15 feet tall, considerably smaller than its more famous Cretaceous counterpart. The hunting behavior of Allosaurus is also often misconstrued. It is sometimes depicted as a solitary hunter, similar to how many envision Tyrannosaurus. However, evidence suggests that Allosaurus may have engaged in pack hunting, working together to bring down larger prey. This cooperative behavior would have made it an even more formidable predator than often portrayed. Lastly, the intelligence of Allosaurus is frequently underestimated in popular media. While not as cerebrally advanced as later theropods, Allosaurus possessed cognitive abilities that likely surpassed many of its contemporaries. Its brain structure suggests it had good sensory perception and the capacity for complex behaviors, making it a more sophisticated hunter than often depicted in films and television shows. Our understanding of Allosaurus has evolved significantly since its discovery in the late 19th century. Initially, this large carnivorous dinosaur was known only from fragmentary remains, leading to misconceptions about its appearance and behavior. Early reconstructions often depicted Allosaurus as a sluggish, tail-dragging beast, reflecting the limited knowledge of dinosaur biology at the time. As more fossils were unearthed and studied, scientists began to paint a more accurate picture of Allosaurus. In the 1970s, the discovery of more complete skeletons revolutionized our understanding of its anatomy. Researchers realized that Allosaurus was a dynamic, agile predator with a lightweight skull and powerful hind limbs capable of quick movements and precise attacks. Recent studies have shed light on Allosaurus hunting behavior. Analysis of bite marks on prey fossils suggests that Allosaurus used its upper jaw like a hatchet, repeatedly striking downward to inflict wounds. This technique differs from the bone-crushing bites of later theropods, like Tyrannosaurus rex, indicating a unique hunting strategy among large carnivorous dinosaurs. Advances in technology have also enhanced our understanding of Allosaurus. Computer simulations and three-dimensional modeling have allowed scientists to study its biomechanics, revealing details about its movement and feeding habits. These insights continue to refine our image of Allosaurus, transforming it from a generic predator to a sophisticated hunter with specialized adaptations for its Jurassic environment. Several notable Allosaurus fossils have been discovered over the years, shedding light on this fearsome Jurassic predator. One of the most famous specimens is nicknamed Big Al, unearthed in Wyoming in 1991. This remarkably complete skeleton belongs to a subadult Allosaurus and shows evidence of numerous injuries and infections, offering valuable insights into the life and death of these ancient carnivores. Another well-known Allosaurus fossil is Big Al II, discovered in 1996 near the original Big Al site. This specimen is even more complete than its namesake, with over 95% of the skeleton preserved. Big Al II has provided paleontologists with crucial information about Allosaurus anatomy and growth patterns. The Cleveland Lloyd Dinosaur Quarry in Utah has yielded a wealth of Allosaurus fossils, including dozens of individuals of various ages. This site has been instrumental in our understanding of Allosaurus behavior and population dynamics. The abundance of specimens from this quarry has allowed scientists to study variations within the species and hypothesize about possible pack hunting behaviors. In Portugal, paleontologists uncovered an Allosaurus specimen that represents one of the most complete theropod skeletons found in Europe. This discovery has expanded our knowledge of Allosaurus distribution and raised questions about the connections between North American and European dinosaur populations during the late Jurassic period. Allosaurus has played a significant role in shaping dinosaur-themed attractions around the world. As one of the most well-known carnivorous dinosaurs from the late Jurassic period, Allosaurus has captured the imagination of both paleontologists and the general public alike. Many museums and science centers feature Allosaurus skeletons or reconstructions as centerpieces in their dinosaur exhibits. The Cleveland Museum of Natural History, for example, displays a famous Allosaurus specimen nicknamed Happy. These exhibits allow visitors to appreciate the impressive size and predatory features of this ancient hunter. Theme parks and dinosaur-focused attractions often include Allosaurus in their displays and animatronic shows. Its recognizable appearance, with large teeth and distinctive head crests, makes it a popular choice for creating thrilling and educational experiences. The Jurassic World franchise has also featured Allosaurus in its films and associated theme park attractions, further cementing its place in popular culture. Educational programs and interactive exhibits frequently use Allosaurus as a prime example when teaching about carnivorous dinosaurs, fossilization processes, and prehistoric ecosystems. Its well-preserved fossil record provides a wealth of information that helps bring the Jurassic period to life for visitors of all ages. Allosaurus holds a significant place in paleontology education as one of the most well-known and extensively studied carnivorous dinosaurs from the late Jurassic period. This formidable predator, whose name means different lizard, serves as an excellent example to teach students about the diversity of theropod dinosaurs and the ecosystems of prehistoric North America. The abundance of Allosaurus fossils, particularly from sites like the Cleveland Lloyd Dinosaur Quarry in Utah, provides researchers and educators with a wealth of information about its anatomy, behavior, and environment. This fossil record allows for detailed reconstructions of Allosaurus, making it a valuable tool for explaining concepts such as skeletal structure, adaptations for predation, and the process of fossilization. Allosaurus also plays a crucial role in demonstrating the evolution of large carnivorous dinosaurs. By comparing Allosaurus to earlier and later theropods, paleontologists can illustrate evolutionary trends in body size, skull shape, and limb proportions. This comparative approach helps students understand the concept of evolutionary change over time and the relationships between different dinosaur groups. Furthermore, Allosaurus fossils have been instrumental in developing theories about dinosaur behavior and physiology. Studies of its bite force, potential hunting strategies, and evidence of injuries and healing have contributed to our understanding of dinosaur biology and ecology. These investigations showcase the scientific method in action, demonstrating how paleontologists use fossil evidence to form and test hypotheses about extinct animals. Allosaurus has captured the imagination of writers and readers alike since its discovery in the late 19th century. This fearsome predator from the Jurassic period has been featured in numerous works of fiction, ranging from classic adventure novels to modern science fiction stories. In literature, Allosaurus is often portrayed as a powerful and agile hunter, embodying the savage nature of prehistoric life. Many authors have used its presence to create tension and excitement in their narratives, particularly in stories set in lost worlds or involving time travel. The dinosaur's large size, sharp teeth, and predatory nature make it an ideal antagonist or obstacle for human characters to overcome. Some works have taken a more speculative approach, imagining how Allosaurus might have evolved if it had survived the mass extinction event at the end of the Cretaceous period. These stories often depict highly intelligent or even technologically advanced versions of the species, exploring themes of alternate evolution and the nature of intelligence. Interestingly, as scientific understanding of dinosaurs has progressed, literary depictions of Allosaurus have also evolved. Modern works tend to portray it with greater accuracy, incorporating current paleontological knowledge about its behavior, physiology, and appearance. This shift reflects the ongoing dialogue between scientific discovery and popular imagination in shaping our understanding of prehistoric life. Allosaurus has significantly influenced dinosaur toy design since its discovery in the late 19th century. This fearsome predator from the Jurassic period has captured the imagination of paleontologists and the public alike, leading to its frequent representation in toy lines and collectibles. Toy manufacturers have often used Allosaurus as a go-to carnivorous dinosaur model, second only to the more famous Tyrannosaurus rex. Its distinctive skull shape, with ridges above the eyes and rows of sharp teeth, has become a standard feature in many dinosaur toy sets. The three-fingered hands of Allosaurus, differing from the two-fingered hands of T-Rex, have also allowed for more varied and dynamic posing options in action figures. The scientific accuracy of Allosaurus toys has evolved over time, reflecting advancements in paleontological knowledge. Early toy designs often depicted Allosaurus with an upright, tail-dragging posture. However, modern toys now show a more horizontal stance with the tail held off the ground, aligning with current scientific understanding of theropod dinosaur anatomy. Allosaurus has also played a role in expanding the color palette of dinosaur toys. While early models were often monochromatic, usually in shades of green or brown, newer Allosaurus figures feature more varied and vibrant color schemes. This shift reflects both changing market preferences and evolving theories about dinosaur appearance and potential camouflage patterns. Allosaurus fossils have been discovered in several locations across North America and Europe, but the most significant and abundant finds have come from the Morrison Formation in the western United States. This geological formation, dating back to the late Jurassic period approximately 150 million years ago, stretches across several states, including Colorado, Utah, Wyoming, and Montana. The Cleveland Lloyd Dinosaur Quarry in Utah stands out as a particularly important site for Allosaurus discoveries. This quarry has yielded more than 46 Allosaurus specimens, making it the richest deposit of Allosaurus fossils in the world. The high concentration of remains at this site has provided paleontologists with valuable insights into Allosaurus anatomy, growth, and population dynamics. Another notable location is Como Bluff in Wyoming, where some of the first Allosaurus fossils were unearthed in the late 19th century. This site played a crucial role in the early understanding of Allosaurus and other dinosaurs from the Jurassic period. The Dinosaur National Monument, straddling the border between Utah and Colorado, has also produced significant Allosaurus specimens alongside other dinosaur species. Outside North America, Allosaurus fossils have been found in Portugal and possibly Tanzania, though these discoveries are less extensive than those in the Morrison Formation. The abundance and quality of Allosaurus fossils from the American West have made this region the primary source of our knowledge about this iconic predator of the Jurassic era. The most complete Allosaurus skeleton ever discovered is known as Big Al. This remarkable fossil was unearthed in 1991 near Shell, Wyoming, in the United States. Big Al, scientifically catalogued as MOR 693, is estimated to be 95% complete, making it an exceptionally rare and valuable find in the world of paleontology. Big Al was a young adult Allosaurus, measuring about 8 meters in length. Despite its relative youth, the skeleton shows evidence of numerous injuries and infections, providing scientists with invaluable insights into the life and health challenges faced by these Jurassic predators. The completeness of the skeleton allows researchers to study the anatomy and biomechanics of Allosaurus in unprecedented detail. The discovery of Big Al has significantly advanced our understanding of Allosaurus and other large theropod dinosaurs. Its well-preserved bones have enabled scientists to create accurate reconstructions and study the growth patterns of these fascinating creatures. The skeleton has also been the subject of several documentaries and museum exhibitions, helping to bring the world of dinosaurs to life for millions of people. While other Allosaurus specimens have been found, none match the completeness and preservation quality of Big Al. This extraordinary fossil continues to be a crucial reference point for paleontologists studying the anatomy, behavior, and evolution of large carnivorous dinosaurs from the late Jurassic period. Paleontologists have unearthed a significant number of Allosaurus fossils since their first discovery in the late 19th century. While it is challenging to provide an exact count, experts estimate that remains from over 100 individual Allosaurus specimens have been excavated from various sites across North America and Europe. The Morrison Formation, a rich fossil bed spanning several states in the western United States, has yielded the majority of Allosaurus discoveries. This formation has been a treasure trove for paleontologists, offering numerous well-preserved specimens that have greatly enhanced our understanding of this formidable Jurassic predator. One of the most famous Allosaurus fossils is a specimen nicknamed Big Al, discovered in Wyoming in 1991. This remarkably complete skeleton has provided invaluable insights into Allosaurus anatomy and behavior. Another notable find is Allosaurus gymnodsini, a species identified from 2 nearly complete skeletons unearthed in Utah. These fossil discoveries continue to shed light on the diversity and distribution of Allosaurus across prehistoric landscapes. As paleontologists explore new sites and re-examine existing collections, the number of identified Allosaurus fossils is likely to increase, further expanding our knowledge of this iconic dinosaur species. Fossilized Allosaurus teeth provide paleontologists with a wealth of information about this fearsome Jurassic predator. These razor-sharp, serrated teeth, some reaching lengths of up to 4 inches, reveal that Allosaurus was a formidable carnivore, perfectly adapted for slicing through the flesh of its prey. The shape and structure of the teeth indicate a diet consisting primarily of other large dinosaurs, including sauropods and stegosaurs. By examining the wear patterns on Allosaurus teeth, scientists can deduce information about its feeding habits and bite force. The presence of scratches and chips on the enamel suggests that Allosaurus frequently encountered bones while feeding, possibly tearing chunks of meat from carcasses. Additionally, the teeth's composition allows researchers to analyze the dinosaur's growth rates and metabolism, providing insights into its life history and physiology. Fossilized teeth also offer clues about the environment in which Allosaurus lived. Trace elements found within the tooth enamel can indicate the types of plants and animals in its ecosystem, as well as the climate conditions of the late Jurassic period. Furthermore, the abundance of Allosaurus teeth found in certain fossil beds helps paleontologists estimate population sizes and distribution patterns of this apex predator. The study of Allosaurus teeth extends beyond individual specimens. By comparing teeth from different fossil sites and geological time periods, scientists can track evolutionary changes within the species and its relatives. This information contributes to our understanding of theropod dinosaur evolution and the complex ecosystems of the Mesozoic era, painting a vivid picture of life on Earth over 150 million years ago. Allosaurus, the fearsome predator of the late Jurassic period, has long captured the imagination of paleontologists and dinosaur enthusiasts alike. When it comes to skin impressions, however, the evidence for Allosaurus is surprisingly scarce. Unlike some other dinosaur species, where researchers have found extensive fossilized skin samples, Allosaurus has been more elusive in this regard. To date, no definitive, large-scale skin impressions from Allosaurus have been discovered. This absence of evidence has left paleontologists with limited direct information about the external appearance of this iconic theropod. However, this does not mean that we are completely in the dark about Allosaurus skin. Some studies have reported potential microscopic skin impressions associated with Allosaurus fossils. These tiny traces, while not providing a comprehensive picture, offer tantalizing hints about the texture and structure of Allosaurus skin. Based on these findings and comparisons with related theropod dinosaurs, scientists speculate that Allosaurus likely had scaly skin, similar to many other large predatory dinosaurs of its time. The search for Allosaurus skin impressions continues, as paleontologists hope that future discoveries might shed more light on the external appearance of this prehistoric hunter. Until then, our understanding of Allosaurus skin remains largely based on inference and comparison with its dinosaurian relatives. The Cleveland Lloyd Dinosaur Quarry in Utah holds immense importance for Allosaurus research, offering paleontologists a treasure trove of fossils from this iconic Jurassic predator. This site has yielded more Allosaurus remains than any other location in the world, with over 40 individual specimens discovered so far. The sheer abundance of Allosaurus fossils at Cleveland Lloyd provides scientists with a unique opportunity to study this species in great detail. Researchers can examine variations between individuals, analyze growth patterns, and gain insights into Allosaurus population dynamics. This wealth of specimens allows for more comprehensive studies on Allosaurus anatomy, behavior, and ecological role within its ancient ecosystem. One of the most intriguing aspects of the Cleveland Lloyd Quarry is the mystery surrounding the high concentration of Allosaurus remains. Scientists have proposed various theories to explain this phenomenon, including the possibility that the site was a predator trap or the result of a mass death event. This enigma continues to fuel ongoing research and debates among paleontologists. The fossils from Cleveland Lloyd have also contributed significantly to our understanding of Allosaurus biomechanics and hunting strategies. By studying the well-preserved bones, scientists have gained valuable insights into how these powerful predators moved, hunted, and interacted with their environment, shedding light on the complex dynamics of the Jurassic period. Paleontologists employ several sophisticated techniques to determine the age of Allosaurus fossils. One primary method is radiometric dating, which measures the decay of radioactive isotopes within the rocks surrounding the fossil. This process provides an accurate estimate of when the sediment containing the Allosaurus remains was deposited. For Allosaurus fossils specifically, scientists often use potassium-argon dating or argon-argon dating. These methods are particularly useful for fossils from the late Jurassic period, when Allosaurus roamed the Earth approximately 150 million years ago. The technique relies on the decay of potassium-40 into argon-40, a process that occurs at a known rate over time. Paleontologists also utilize biostratigraphy, comparing the layers in which Allosaurus fossils are found to other rock formations with known ages. By identifying specific index fossils, such as certain species of plants or marine organisms, scientists can correlate different rock layers and establish a relative age for the Allosaurus remains. Additionally, paleomagnetic dating can provide further evidence. This method examines the orientation of magnetic minerals in the surrounding rock, which aligns with the Earth's magnetic field at the time of rock formation. By comparing this to known patterns of magnetic pole reversals throughout Earth's history, scientists can narrow down the age of Allosaurus fossils with greater precision. Paleontologists employ a variety of specialized techniques when excavating Allosaurus fossils. The process begins with careful prospecting, where scientists search for bone fragments exposed on the surface. Once a promising site is identified, they use tools like picks, shovels, and brushes to carefully remove the top layers of rock and soil. As they get closer to the fossil, the tools become more delicate. Small chisels, dental picks, and even toothbrushes are used to gently remove the surrounding matrix without damaging the precious bones. Paleontologists often apply a hardening solution to fragile fossils to prevent them from crumbling during excavation. For larger specimens, plaster jackets are created to protect the fossils during transport. The team carefully wraps the specimen and surrounding rock in wet plaster bandages, creating a protective shell. Once the plaster hardens, the entire block can be safely removed and transported to a laboratory for further preparation and study. Advanced imaging techniques like ground-penetrating radar or computed tomography scans may be used to locate fossils hidden within rock layers or to study specimens without damaging them. These methods allow scientists to peer inside fossils and surrounding rock, revealing details about the internal structure of Allosaurus bones and providing valuable insights into the anatomy and life of these ancient predators. Allosaurus fossils undergo a meticulous preparation process before they can be studied or displayed. When paleontologists unearth these ancient predator remains, they carefully extract the fossils along with surrounding rock, creating a protective jacket of plaster to safeguard the delicate bones during transport. Once in the laboratory, skilled technicians begin the painstaking task of removing the rock matrix from around the fossilized bones. This process, known as preparation, requires specialized tools and techniques. Preparators use small pneumatic hammers, dental picks, and even acid baths to slowly and carefully expose the fossil material without damaging it. As the bones are revealed, they are strengthened with special consolidants to prevent crumbling. Missing fragments may be reconstructed using casts or three-dimensional printing techniques, allowing scientists to study the complete anatomy of the Allosaurus. Throughout this process, detailed notes and photographs document each step, preserving crucial information about the fossil's original position and condition. For display purposes, the prepared Allosaurus fossils may be mounted on custom-built armatures that support the bones in lifelike poses. These mounts are carefully engineered to distribute the weight of the heavy fossils and protect them from damage, while also allowing for future study and maintenance. The result is an awe-inspiring glimpse into the world of these fearsome Jurassic predators, ready to captivate museum visitors and provide invaluable data for ongoing paleontological research. Recent Allosaurus fossil discoveries have significantly expanded our knowledge of this iconic Jurassic predator. In Utah's Morrison Formation, paleontologists unearthed a remarkably complete Allosaurus skeleton with preserved skin impressions. This rare find has provided unprecedented insights into the dinosaur's external appearance, revealing a scaly texture similar to modern reptiles, but with unique patterns that may have served as camouflage or for species recognition. Another groundbreaking discovery in Portugal has challenged previous assumptions about Allosaurus distribution. The well-preserved remains found in the Lourinhã Formation suggest that Allosaurus, or a closely related species, inhabited Europe during the late Jurassic period. This finding indicates a wider geographical range for the genus than previously thought, prompting scientists to re-evaluate Allosaurus migration patterns and evolutionary history. Furthermore, a series of Allosaurus footprints discovered in Wyoming has shed new light on the dinosaur's locomotion and behavior. The trackway suggests that Allosaurus may have been capable of running at speeds up to 25 miles per hour, faster than earlier estimates. This discovery has implications for understanding predator-prey dynamics in Jurassic ecosystems and has led to revised interpretations of Allosaurus hunting strategies. These recent findings collectively paint a more detailed picture of Allosaurus as a highly adaptable and widespread predator. They highlight the importance of continued fossil exploration in enhancing our understanding of prehistoric life and demonstrate how new discoveries can reshape our perceptions of even well-known dinosaur species. Allosaurus, a fearsome predator of the late Jurassic period, primarily hunted large herbivorous dinosaurs. These powerful carnivores, with their sharp serrated teeth and strong jaws, were well equipped to take down prey much larger than themselves. Their main targets included the long-necked sauropods, such as Diplodocus and Apatosaurus, as well as the heavily armored stegosaurs. Evidence from fossilized tooth marks and preserved stomach contents suggests that Allosaurus also preyed upon smaller dinosaurs like Camptosaurus and young Camarasaurus. These agile hunters likely employed a combination of ambush tactics and pack hunting to bring down their massive victims, using their strong legs and sharp claws to latch onto prey before delivering deadly bites. Scavenging likely played a role in the Allosaurus diet as well. Like many large predators, they would have taken advantage of already dead or dying animals when the opportunity arose. This opportunistic feeding behavior would have helped Allosaurus survive during times when live prey was scarce or hunting proved unsuccessful. While plants were not a significant part of their diet, some scientists speculate that Allosaurus might have occasionally consumed tough plant material to aid in digestion, similar to how some modern carnivores eat grass. However, their primary sustenance came from the flesh of other dinosaurs, making them apex predators of their ecosystem. Allosaurus, a formidable predator of the late Jurassic period, had a diet that set it apart from other large theropods of its time. Unlike some of its contemporaries, Allosaurus was a versatile and opportunistic hunter, capable of taking down a wide range of prey. This carnivore's diet primarily consisted of large herbivorous dinosaurs, including sauropods and stegosaurs. However, Allosaurus was not limited to these massive prey items. It also hunted smaller dinosaurs and possibly even scavenged when the opportunity arose. This diverse diet allowed Allosaurus to thrive in various environments and adapt to changing prey availability. One key difference in Allosaurus's feeding strategy was its relatively weak bite force compared to other large theropods. Instead of relying on a powerful bite to subdue prey, Allosaurus used its sharp, serrated teeth like blades, slashing at its victims to inflict severe wounds. This hunting technique, combined with its agility and strong forelimbs, allowed Allosaurus to tackle prey that might have been too dangerous for other predators to approach. Furthermore, evidence suggests that Allosaurus may have engaged in pack hunting behavior, which would have enabled it to take down even larger prey than it could manage alone. This social hunting strategy, if confirmed, would represent another significant difference in its dietary habits compared to some other large theropods that were primarily solitary hunters. Allosaurus, a fearsome predator from the late Jurassic period, has left us several clues about its eating habits. Fossil evidence provides insight into the diet and hunting behavior of this large theropod dinosaur. One of the most compelling pieces of evidence comes from bite marks found on the bones of other dinosaurs. Paleontologists have discovered fossils of plant-eating dinosaurs like Stegosaurus with distinctive tooth marks that match the shape and size of Allosaurus teeth. These marks suggest that Allosaurus actively hunted or scavenged these herbivores. Additionally, fossilized stomach contents have been found in some Allosaurus specimens. These contents include bone fragments from various prey animals, indicating that Allosaurus was indeed a carnivore with a diverse diet. The structure of Allosaurus teeth also supports its carnivorous nature, as they were sharp, serrated, and well suited for slicing through flesh. Furthermore, studies of Allosaurus skull biomechanics reveal that it had a relatively weak bite force compared to its body size. This suggests that rather than crushing bones, Allosaurus likely used its jaws to strip meat from carcasses, employing a feeding strategy similar to modern-day Komodo dragons. This evidence paints a picture of Allosaurus as an opportunistic predator, capable of taking down live prey and scavenging when necessary. Allosaurus, a large carnivorous dinosaur from the late Jurassic period, was indeed a formidable predator. However, the question of whether it could take down sauropods on its own is complex and subject to debate among paleontologists. Allosaurus was well equipped for hunting, with sharp, serrated teeth and powerful jaws. It stood up to 30 feet long and weighed up to 2 tons. Despite its impressive size, Allosaurus would have faced significant challenges when confronting fully grown sauropods, which were often much larger. Many sauropods, such as Diplodocus or Brachiosaurus, could reach lengths of over 80 feet and weigh up to 30 tons or more. Their sheer size would have made them difficult targets for a solitary Allosaurus. The long necks and tails of sauropods could have been used as defensive weapons, potentially causing serious injury to an attacking predator. Given these factors, it's more likely that Allosaurus primarily hunted younger or smaller sauropods, or attacked larger ones only when they were already weakened or isolated. Some evidence suggests that Allosaurus might have hunted in packs, which would have increased their chances of successfully taking down larger prey. However, the social behavior of Allosaurus remains a topic of ongoing research and discussion in the scientific community. Allosaurus, one of the largest predatory dinosaurs of the Jurassic period, was a formidable hunter. However, recent evidence suggests that scavenging also played a significant role in its feeding behavior. Paleontologists have found Allosaurus teeth marks on the bones of large herbivorous dinosaurs, indicating that these carnivores fed on already dead animals. This scavenging behavior was likely an important survival strategy for Allosaurus. By consuming carrion, these dinosaurs could obtain valuable nutrients without expending energy on hunting or risking injury from confronting live prey. This opportunistic feeding approach would have been particularly beneficial during times of scarcity or when suitable live prey was difficult to find. Interestingly, studies of Allosaurus skull mechanics have revealed that its bite force was relatively weak compared to other large theropods. This suggests that Allosaurus may have been better adapted for flesh stripping from carcasses rather than delivering killing bites to live prey. This physical characteristic further supports the idea that scavenging was a regular part of its diet. However, it is important to note that Allosaurus was not solely a scavenger. Evidence of active hunting behavior has also been found, indicating that these dinosaurs employed a mixed feeding strategy. This combination of hunting and scavenging would have allowed Allosaurus to thrive in the diverse ecosystems of the late Jurassic period, adapting its feeding habits to available food sources and environmental conditions. Allosaurus, a fearsome predator of the late Jurassic period, possessed teeth that were perfectly adapted for its carnivorous lifestyle. These razor-sharp, serrated blades were designed for slicing through the flesh and bone of its prey with devastating efficiency. Unlike the robust, bone-crushing teeth of some other large theropods, Allosaurus had relatively slender, curved teeth. This shape allowed them to tear off chunks of meat from their victims, which likely included large sauropods and other dinosaurs. The backwards curve of the teeth ensured that once they sank into flesh, the prey could not easily escape. The serrations on the edges of Allosaurus teeth were particularly fine, almost like the edge of a steak knife. This feature made them incredibly effective at cutting through tough dinosaur hide and muscle. Additionally, Allosaurus could constantly replace its teeth throughout its lifetime, ensuring it always had a fresh set of sharp tools for hunting. These dental adaptations, combined with its powerful jaws and large size, made Allosaurus a formidable predator in the Jurassic ecosystem. Its teeth were a crucial part of its success, allowing it to tackle a wide range of prey and dominate as one of the apex predators of its time. Coprolites from Allosaurus provide valuable insights into the feeding habits of this formidable Jurassic predator. These fossilized fecal remains contain a wealth of information, allowing paleontologists to piece together the dietary preferences and hunting behaviors of Allosaurus. Analysis of Allosaurus coprolites has revealed fragments of crushed bone, suggesting that this theropod dinosaur had a powerful bite force capable of splintering the bones of its prey. This evidence supports the idea that Allosaurus was an active predator rather than a scavenger, as it could efficiently process and digest bone material. The coprolites also contain traces of plant material, which initially puzzled researchers. However, this vegetation is now believed to have come from the stomach contents of herbivorous prey animals, indicating that Allosaurus primarily hunted plant-eating dinosaurs. This finding aligns with other fossil evidence, such as tooth marks found on the bones of large herbivorous dinosaurs like Stegosaurus and Camarasaurus. Furthermore, the composition of these fossilized droppings provides clues about the Allosaurus's digestive system. The presence of certain minerals and the overall structure of the coprolites suggest that Allosaurus had a relatively efficient digestive process, allowing it to extract maximum nutrition from its prey. This efficiency would have been crucial for supporting the energy demands of such a large, active predator in the competitive ecosystem of the late Jurassic period. Allosaurus, one of the most fearsome predators of the late Jurassic period, underwent significant changes in its diet as it matured from a juvenile to an adult. This transformation reflects not only the dinosaur's physical growth, but also its evolving role in the prehistoric ecosystem. Young Allosaurus, with their smaller size and less developed hunting skills, likely focused on smaller prey. They would have targeted juvenile dinosaurs, small mammals, and possibly even insects. Their diet at this stage was more opportunistic, taking advantage of easier-to-catch meals that required less risk and energy expenditure. As Allosaurus grew, its diet shifted towards larger prey. Adolescent individuals began to hunt medium-sized dinosaurs, including ornithopods and smaller sauropods. This transition period saw the developing predator honing its hunting techniques and building the strength needed for more challenging pursuits. Fully grown Allosaurus, reaching lengths of up to 30 to 40 feet, became apex predators capable of taking down large sauropods and other formidable dinosaurs. Their powerful jaws and serrated teeth were well suited for slicing through tough dinosaur hide. Adult Allosaurus likely engaged in pack hunting, allowing them to tackle even larger prey that would have been too dangerous for a solitary hunter. This dietary progression from small, easy prey to large, challenging quarry mirrors the Allosaurus's growth from a vulnerable juvenile to a dominant force in the Jurassic landscape. Allosaurus was not the only large carnivore roaming the prehistoric landscape during the late Jurassic period. Several other formidable predators shared its ecosystem and competed for similar prey. One notable rival was Ceratosaurus, a medium-sized theropod with distinctive horns on its skull. Though smaller than Allosaurus, Ceratosaurus was still a capable hunter that likely targeted similar prey. Another significant competitor was Torvosaurus, a large theropod that rivaled Allosaurus in size. With its powerful jaws and sharp teeth, Torvosaurus was well equipped to take down large, herbivorous dinosaurs, potentially leading to conflicts with Allosaurus over food sources. Saurophaganax, sometimes considered a larger relative of Allosaurus, was another apex predator that inhabited the same regions. This massive carnivore may have been at the top of the food chain, possibly outcompeting Allosaurus for larger prey items. Additionally, smaller predators like Ornitholestes and various species of pterosaurs, while not direct competitors for large prey, would have competed with juvenile Allosaurus for smaller animals. This complex ecosystem of carnivores created a challenging environment where Allosaurus had to adapt and thrive amidst fierce competition for resources. Allosaurus, a fearsome predator of the late Jurassic period, played a crucial role in shaping herbivore populations within its ecosystem. As a large theropod dinosaur, Allosaurus was an apex predator, standing at the top of the food chain and exerting significant influence on the animals it hunted. The presence of Allosaurus likely kept herbivore populations in check through direct predation. By targeting weaker or slower individuals, Allosaurus helped maintain the overall health and genetic fitness of herbivore herds. This selective pressure encouraged the evolution of faster, more alert, and potentially larger herbivores as a means of defense against predation. Allosaurus hunting behavior also influenced herbivore distribution and movement patterns. Prey species would have needed to remain vigilant and may have developed complex social structures and herd behaviors to protect themselves. This could have led to changes in grazing patterns and habitat use, indirectly affecting plant life and the broader ecosystem. The impact of Allosaurus extended beyond its immediate prey. As a large predator, it would have competed with other carnivorous dinosaurs, potentially influencing their populations and hunting behaviors as well. This complex web of interactions highlights the vital role Allosaurus played in maintaining the delicate balance of its ancient ecosystem. Allosaurus, one of the most fearsome predators of the late Jurassic period, took several years to reach its full adult size. These large theropod dinosaurs grew rapidly during their early years, but the process of attaining their maximum dimensions was not instantaneous. Studies of Allosaurus fossils and growth rings in their bones suggest that these carnivorous giants reached their adult size in approximately 15 to 20 years. During this growth period, young Allosaurus individuals would have increased in weight from a few kilograms at hatching to over 1,000 kilograms as fully grown adults. The growth rate of Allosaurus was not constant throughout its life. Like many large dinosaurs, it experienced a period of accelerated growth during its juvenile years, followed by a gradual slowing as it approached adulthood. This growth pattern allowed young Allosaurus to quickly reach a size where they could compete for resources and avoid predation by larger carnivores. Interestingly, even after reaching their adult size, Allosaurus continued to grow slowly throughout their lives. This continuous growth, albeit at a much slower rate, is a characteristic shared by many reptiles and some dinosaurs. It meant that the oldest and largest Allosaurus specimens could potentially reach sizes significantly greater than the average adult. Allosaurus, the fearsome predator of the late Jurassic period, has long captured our imagination. While we have a wealth of information about their adult forms from fossil remains, our knowledge of their eggs and nesting behavior is more limited. However, recent discoveries and careful analysis have provided some intriguing insights into the early life of these ancient carnivores. Paleontologists have found fossilized Allosaurus eggs, though they are quite rare. These eggs were likely oval in shape and had a hard, calcified shell, similar to those of modern birds and crocodiles. Based on comparisons with related dinosaur species, scientists estimate that Allosaurus eggs may have been about 20 to 30 centimeters long, roughly the size of a football. As for nesting behavior, evidence suggests that Allosaurus, like many other theropod dinosaurs, likely laid their eggs in shallow, ground-level nests. These nests were probably simple depressions in the earth, possibly lined with vegetation to provide some insulation. It's believed that Allosaurus may have laid their eggs in small clutches, perhaps containing 8 to 12 eggs each. While direct evidence of parental care in Allosaurus is scarce, studies of related theropod species hint at the possibility of some level of nest attendance. Adult Allosaurus may have guarded their nests to protect them from predators, and there's a chance they might have incubated the eggs by sitting on them, similar to modern birds. However, more fossil evidence is needed to confirm these behaviors definitively in Allosaurus. Juvenile Allosaurus, like many young dinosaurs, exhibited notable differences from their adult counterparts. These differences were not just in size, but also in proportions and features that changed as they matured. Young Allosaurus had longer, more slender limbs relative to their body size, which likely made them more agile and swift. This adaptation would have been crucial for evading larger predators and chasing down smaller, faster prey. The skull structure of juvenile Allosaurus was also distinct. Their snouts were shorter and more rounded, with less pronounced ridges and horns compared to adults. Their eye sockets were proportionally larger, a common trait in young animals that aids in visual learning and development. The teeth of young Allosaurus were smaller and more numerous, gradually being replaced by fewer, larger teeth as they grew. Interestingly, the hunting behavior of juvenile Allosaurus likely differed from adults. Their lighter build and different tooth structure suggest they may have pursued smaller, more agile prey. As they matured and gained size and strength, their prey preference would have shifted to larger, more formidable targets. This change in diet and hunting strategy would have reduced competition between juveniles and adults within the same species. The growth rate of Allosaurus was rapid, with individuals reaching near adult size within 10 to 15 years. This quick maturation would have been advantageous in the competitive and often harsh environment of the late Jurassic period, allowing young Allosaurus to quickly grow into their role as apex predators. Allosaurus was a large carnivorous dinosaur that lived during the late Jurassic period, approximately 150 million years ago. Based on fossil evidence and studies of bone structure, paleontologists estimate that Allosaurus had a lifespan of about 20 to 25 years. This estimate is derived from analyzing growth rings in fossilized bones, similar to how we determine the age of trees. These fearsome predators reached their adult size relatively quickly, growing rapidly in their early years. They likely achieved sexual maturity around the age of 15, allowing them to reproduce and pass on their genes before reaching the end of their life expectancy. However, it's important to note that many Allosaurus individuals probably didn't reach their full potential lifespan due to the harsh realities of their environment, including competition, injuries, and diseases. Interestingly, some Allosaurus fossils show signs of healed injuries, suggesting that these dinosaurs were resilient and could survive significant trauma. This ability to recover from wounds might have contributed to some individuals living longer lives, possibly approaching or even exceeding the estimated 25-year lifespan. Allosaurus, one of the most fearsome predators of the Jurassic period, exhibited a remarkable growth rate compared to many other theropod dinosaurs. Studies of Allosaurus fossils indicate that these carnivores reached their adult size in about 15 to 19 years, which is relatively fast for a large theropod. This rapid growth allowed Allosaurus to attain its impressive adult length of up to 33 feet more quickly than some of its contemporaries and later relatives. For instance, Tyrannosaurus rex, which lived much later during the Cretaceous period, took up to 20 years or more to reach its full size. The swift maturation of Allosaurus likely gave it an evolutionary advantage, allowing individuals to become formidable predators earlier in life. This rapid growth might have been an adaptation to the competitive environment of the late Jurassic, where multiple large predatory species coexisted. Interestingly, the growth rate of Allosaurus was not constant throughout its life. Like many dinosaurs, it experienced rapid growth during its juvenile years, which then slowed as the animal approached adulthood. This pattern of growth, combined with its overall rapid maturation, made Allosaurus a particularly successful predator in its ancient ecosystem. Paleontologists have uncovered fascinating evidence suggesting that Allosaurus, a fearsome predator of the late Jurassic period, may have exhibited parental care behaviors. This insight comes from fossil discoveries and careful analysis of bone beds where multiple Allosaurus remains have been found together. One key piece of evidence comes from the Cleveland Lloyd Dinosaur Quarry in Utah, where numerous Allosaurus fossils of varying ages have been discovered in close proximity. The presence of juvenile and adult specimens in the same location hints at the possibility of family groups or social behavior. This arrangement is similar to what we see in modern animals that practice parental care. Further support for Allosaurus parental care comes from studies of bone growth patterns. Some juvenile Allosaurus fossils show rapid growth rates, suggesting they received abundant nutrition. This could indicate that parents were actively providing food for their young, a behavior observed in many modern predatory birds and reptiles. Additionally, trace fossils such as footprints have provided clues about Allosaurus behavior. Some trackways show adult and juvenile footprints together, potentially representing family groups moving as a unit. While not definitive proof, these findings contribute to the growing body of evidence supporting the idea that Allosaurus may have invested time and energy in caring for its offspring. Allosaurus, a fearsome predator of the late Jurassic period, underwent significant changes in its hunting abilities as it matured. Juvenile Allosaurus began life as relatively swift and agile hunters, targeting smaller prey items that their still developing bodies could manage. Their lighter frames and proportionally longer legs allowed them to chase down swift ornithopods and other nimble dinosaurs. As Allosaurus grew, its hunting strategy evolved to match its increasing size and power. Adult Allosaurus, reaching lengths of up to 30 feet, became apex predators capable of taking down much larger prey. Their massive skulls, equipped with serrated teeth and powerful jaw muscles, allowed them to deliver devastating bites to their victims. The adults likely employed ambush tactics, using their strong legs to launch surprise attacks on larger herbivores like stegosaurs and sauropods. Fossil evidence suggests that adult Allosaurus hunted in loose packs, a behavior that might have developed as they aged. This cooperative hunting strategy would have allowed them to tackle even larger prey, working together to bring down massive sauropods that would have been too dangerous for a solitary hunter. The aging Allosaurus also developed stronger neck muscles and more robust skull structures, enabling them to withstand the forces involved in attacking and subduing large prey. This physical development, combined with years of hunting experience, made older Allosaurus formidable predators at the top of their ecosystem. Allosaurus, a fearsome predator of the late Jurassic period, lived approximately 150 million years ago. These large theropod dinosaurs began their lives as small, vulnerable hatchlings, emerging from eggs laid in shallow, earthen nests. At this stage, young Allosaurus were likely no larger than a chicken and covered in downy feathers for insulation. As they grew, juvenile Allosaurus quickly developed into more formidable hunters. Their growth rate was rapid, and by their teenage years, they could have reached lengths of up to 20 feet. During this phase, their distinctive skull features began to take shape, including the iconic ridges above their eyes that gave them a menacing appearance. Reaching adulthood, Allosaurus attained their full size, measuring up to 33 feet in length and weighing as much as 2 tons. Their powerful jaws, lined with sharp, serrated teeth, made them apex predators of their ecosystem. Adult Allosaurus likely hunted in packs, taking down large herbivorous dinosaurs such as Stegosaurus and Diplodocus. The final stage of an Allosaurus's life remains somewhat mysterious to paleontologists. While we know they could live for several decades, the exact lifespan is uncertain. As they aged, these dinosaurs likely faced increasing competition from younger, stronger individuals and may have become more solitary in their hunting habits. Understanding the life cycle of Allosaurus provides crucial insights into the complex ecosystems of the Jurassic period and the evolution of large predatory dinosaurs. Allosaurus, a fearsome predator from the late Jurassic period, exhibited notable sexual dimorphism, though the differences between males and females were not as extreme as in some other dinosaur species. Paleontologists have identified several key features that distinguish male and female Allosaurus specimens. One of the most significant differences was in overall size and robustness. Male Allosaurus tended to be larger and more heavily built than their female counterparts. This size difference likely played a role in mating rituals and competition for mates, with larger males potentially having an advantage in attracting females or fending off rival suitors. Skeletal variations also provide clues to sexual dimorphism in Allosaurus. Males typically had more pronounced muscle attachment points on their bones, particularly in the skull and limbs. This suggests that male Allosaurus may have engaged in more aggressive behaviors or had slightly different hunting strategies compared to females. Interestingly, some studies have suggested that female Allosaurus may have had wider pelvic openings to accommodate egg-laying. However, this characteristic is difficult to confirm definitively due to the limited number of well-preserved pelvic fossils. Despite these differences, both male and female Allosaurus were formidable predators, each playing crucial roles in their ecosystem during the late Jurassic period. Young Allosaurus faced numerous challenges in their journey to adulthood. These large carnivorous dinosaurs, which roamed North America during the late Jurassic period, had to navigate a perilous world from the moment they hatched. One of the primary threats came from their own kind. Adult Allosaurus were known to be cannibalistic, not hesitating to prey on smaller, younger individuals. This meant that juveniles had to constantly be on alert, even within their own species. They needed to develop keen senses and agility to avoid becoming a meal for their larger counterparts. Food scarcity posed another significant challenge. Young Allosaurus lacked the size and strength to take down large prey, forcing them to compete with other small carnivores for limited resources. They had to hone their hunting skills quickly, learning to catch fast-moving smaller prey while avoiding confrontations with larger predators. Environmental factors also played a crucial role in their survival. The late Jurassic climate was prone to seasonal changes and occasional droughts. Young Allosaurus had to adapt to these fluctuations, finding ways to locate water sources and endure periods of scarcity. Additionally, they faced threats from other predators and even large herbivores that could easily injure or kill an inexperienced juvenile. Only the most resilient and adaptable young Allosaurus would survive to reach the formidable size and strength of adulthood. During the time of Allosaurus, approximately 150 million years ago in the late Jurassic period, Earth's climate was significantly different from what we experience today. The world was much warmer, with no polar ice caps and higher sea levels. This created a greenhouse environment that supported lush vegetation and diverse ecosystems. Temperatures were more consistent across the globe, with milder winters and warmer summers. The average global temperature was estimated to be around 25 degrees Celsius, about 10 degrees warmer than our current average. This warmth allowed for the proliferation of large reptiles like Allosaurus, which thrived in these conditions. The atmosphere contained higher levels of carbon dioxide, contributing to the greenhouse effect and supporting abundant plant life. Rainfall patterns were different, with more precipitation in areas that are now arid. This led to the formation of extensive forests and swamps, providing ample food sources for herbivorous dinosaurs, which in turn sustained predators like Allosaurus. Seasonal changes were less pronounced than they are today, but still played a role in the life cycles of plants and animals. The warm, stable climate allowed for year-round activity of large dinosaurs, including Allosaurus, which could hunt and grow without the constraints of harsh winters or extreme temperature fluctuations. Allosaurus was a dominant predator during the late Jurassic period, roaming the landscapes of North America and Europe approximately 150 million years ago. These powerful carnivores thrived in a variety of environments, but were particularly well suited to the warm, semi-arid regions that characterized much of their habitat. The late Jurassic world was quite different from our own, with higher sea levels and no polar ice caps. Allosaurus inhabited a range of ecosystems, including open woodlands, floodplains, and coastal areas. These environments provided ample hunting opportunities, with an abundance of large herbivorous dinosaurs such as Stegosaurus and Diplodocus serving as potential prey. Fossil evidence suggests that Allosaurus was adaptable, capable of surviving in both wetter and drier conditions. However, it seemed to prefer areas with a mix of open spaces for pursuit and some vegetation for ambush hunting. This versatility likely contributed to its success as a top predator for millions of years. The presence of Allosaurus fossils in multiple locations across 2 continents indicates that these theropods were able to thrive in diverse geographical settings, from the Morrison Formation in North America to sites in Portugal. This adaptability highlights the impressive survival skills of these fearsome Jurassic predators. Allosaurus, a fearsome predator of the late Jurassic period, evolved several key adaptations to thrive in its changing environment. This large theropod dinosaur developed powerful legs and a strong tail, allowing it to move swiftly across varied terrain. Such agility was crucial as the landscape shifted from lush forests to more open areas, requiring Allosaurus to chase down prey over longer distances. The skull of Allosaurus underwent significant modifications, resulting in a lighter yet stronger structure. This adaptation enabled the dinosaur to deliver powerful bites while minimizing the risk of injury during hunts. Its teeth became serrated and blade-like, perfect for slicing through the tough hides of its prey, which included large, herbivorous dinosaurs like Stegosaurus. As the climate fluctuated, Allosaurus developed a more efficient respiratory system. This allowed it to regulate its body temperature more effectively and maintain high energy levels in diverse conditions. The dinosaur's keen senses, particularly its vision, also improved, helping it detect prey and potential threats in changing environments. Allosaurus also adapted its hunting strategies, becoming more of an opportunistic predator. This flexibility allowed it to survive in various ecosystems, from coastal plains to inland forests, as it could take advantage of different food sources as they became available. These adaptations collectively enabled Allosaurus to remain a dominant predator for millions of years, showcasing the remarkable ability of species to evolve in response to environmental changes. Allosaurus roamed the landscapes of North America during the late Jurassic period, about 150 million years ago. This formidable predator shared its environment with a diverse array of other dinosaur species, creating a rich and complex ecosystem. Among the most notable companions of Allosaurus were the massive sauropods. These long-necked herbivores, including Diplodocus, Apatosaurus, and Brachiosaurus, dominated the landscape with their immense size. These gentle giants likely served as prey for Allosaurus, though taking down such enormous creatures would have been a challenging and dangerous task. Smaller herbivores also inhabited the same regions. Stegosaurus, with its distinctive row of plates and spiked tail, was a contemporary of Allosaurus. The swift-footed Camptosaurus and the armored Gargoylosaurus also shared these territories, adding to the diversity of potential prey for the predatory Allosaurus. Other carnivorous dinosaurs competed with Allosaurus for food and territory. These included the smaller but equally fierce Ceratosaurus and the agile Ornitholestes. This variety of predators and prey created a dynamic and competitive environment, shaping the hunting strategies and behaviors of Allosaurus throughout its reign in the Jurassic ecosystem. During the time of Allosaurus, approximately 150 million years ago in the late Jurassic period, the geography of Earth was vastly different from what we see today. The continents were still joined together in a supercontinent called Pangaea, which had begun to break apart. This massive landmass was surrounded by a single, enormous ocean known as Panthalassa. The climate during this period was generally warmer and more humid than it is now, with no polar ice caps. This led to higher sea levels, which submerged much of what we now know as coastal areas and created vast, shallow seas across many continental interiors. These inland seas were home to a diverse array of marine life, including plesiosaurs and ichthyosaurs. The landscape where Allosaurus roamed was dominated by lush fern prairies, conifer forests, and cycad groves, rather than the grass-covered plains and deciduous forests we see in many areas today. The absence of flowering plants, which had not yet evolved, meant that the flora was quite different from modern ecosystems. The geography of Allosaurus's time also featured active tectonics, with mountain-building processes in full swing. This dynamic environment, coupled with the warm, wet climate, created a world that was both familiar and alien compared to our modern Earth, setting the stage for the diverse and often gigantic life forms of the Jurassic, including the fearsome Allosaurus itself. During the late Jurassic period, when Allosaurus roamed, the landscape was dominated by lush vegetation quite different from what we see today. Coniferous trees, such as ancient relatives of modern pines, firs, and cypresses, were widespread, forming vast forests. These trees provided shelter and food for many of the herbivorous dinosaurs that Allosaurus hunted. Ferns were also abundant, carpeting the forest floors and open areas. These plants, which had been around for millions of years before the dinosaurs, thrived in the warm, humid climate of the time. Alongside ferns, early flowering plants were just beginning to appear, though they were not yet the dominant form of vegetation. Cycads, which resemble palm trees but are more closely related to conifers, were another common sight in Allosaurus's world. These plants, with their thick trunks and crown of stiff leaves, provided an important food source for many herbivorous dinosaurs. Ginkgo trees, still found today but much rarer, were also present in the Jurassic landscape. In wetter areas, horsetails and club mosses grew in abundance. These primitive plants, much larger than their modern descendants, contributed to the dense, swampy environments that characterized parts of the Jurassic world. This diverse plant life supported a complex ecosystem, providing the foundation for the food chain that allowed large predators like Allosaurus to thrive. Allosaurus thrived in the late Jurassic period, approximately 150 million years ago. This predatory dinosaur evolved in a world of lush forests and expansive floodplains, an environment that shaped its physical characteristics and hunting strategies. The varied terrain of Allosaurus's habitat, ranging from open plains to densely vegetated areas, influenced the development of its powerful legs and agile body. These adaptations allowed it to navigate diverse landscapes effectively, whether pursuing prey or evading larger predators. The abundance of large herbivorous dinosaurs in its ecosystem played a crucial role in Allosaurus's evolution as an apex predator. Its strong jaws and sharp, serrated teeth were perfectly suited for tearing through the tough hides of its prey, which included long-necked sauropods and heavily armored stegosaurs. Climate fluctuations during the late Jurassic also impacted Allosaurus's development. Periods of drought likely led to the evolution of efficient hunting techniques and the ability to survive on less frequent meals, traits that would have given Allosaurus a significant advantage in a challenging and competitive environment. Allosaurus, the fearsome predator of the late Jurassic period, faced numerous natural disasters that could have impacted its population. Volcanic eruptions were a significant threat, spewing ash and toxic gases into the atmosphere. These events could have caused rapid climate changes, altering vegetation and affecting the entire food chain Allosaurus depended on. Prolonged droughts presented another challenge. As water sources dried up, herbivorous dinosaurs, the primary prey of Allosaurus, might have migrated or died off, leaving the carnivore with limited food options. This scarcity could have led to increased competition among Allosaurus individuals and potentially reduced their numbers. Massive wildfires, possibly ignited by lightning strikes, could have devastated the landscapes where Allosaurus hunted. These fires would have destroyed habitats and driven away prey, forcing Allosaurus to relocate or face starvation. Additionally, the smoke and particulates from large-scale fires could have caused respiratory issues for these dinosaurs. Flooding events, particularly in low-lying areas, posed yet another threat. While Allosaurus was likely a strong swimmer, prolonged inundation of its hunting grounds could have disrupted its lifestyle and forced it into unfamiliar territories. These floods might have also drowned or displaced many of the herbivorous dinosaurs Allosaurus preyed upon, further challenging its survival. Seasonal changes significantly influenced the behavior of Allosaurus, one of the most fearsome predators of the late Jurassic period. As the climate shifted throughout the year, these large theropod dinosaurs adapted their hunting and social patterns to survive. During warmer seasons, Allosaurus likely increased its activity levels, taking advantage of the abundance of prey. The pleasant weather conditions allowed for more frequent hunting expeditions and potentially longer range movements. This period might have also coincided with breeding seasons, leading to changes in social dynamics and territorial behaviors. As temperatures cooled, Allosaurus probably adjusted its metabolism and hunting strategies. While not believed to hibernate, these dinosaurs may have reduced their activity levels to conserve energy. They might have focused on hunting prey that was similarly affected by the colder weather, targeting animals weakened by harsh conditions or scavenging more frequently. Seasonal migrations of herbivorous dinosaurs would have also impacted Allosaurus behavior. These predators might have followed herds of potential prey as they moved to find better grazing grounds, adapting their own movements to ensure a steady food supply throughout the year. This dynamic relationship between predator and prey, driven by seasonal changes, shaped the ecosystem of the late Jurassic world. Fossil evidence provides valuable insights into the preferred habitat of Allosaurus, a large carnivorous dinosaur that lived during the late Jurassic period. Paleontologists have uncovered Allosaurus remains in several locations across western North America, particularly in the Morrison Formation. This geological formation stretches across several states, including Colorado, Utah, and Wyoming. The environment of the Morrison Formation during the time of Allosaurus was quite different from what we see today. It consisted of a mix of forests, open woodlands, and river systems. This diverse landscape offered a variety of habitats and prey options for Allosaurus. The presence of numerous Allosaurus fossils in these areas suggests that the dinosaur thrived in this type of environment. Alongside Allosaurus fossils, researchers have found remains of other dinosaurs, including large herbivores like Stegosaurus and Diplodocus. This indicates that Allosaurus lived in an ecosystem rich with potential prey, supporting its role as an apex predator. The abundance of these herbivores in the same locations as Allosaurus fossils further supports the idea that it preferred habitats with ample hunting opportunities. Sedimentary evidence from fossil sites also provides clues about the climate during the time of Allosaurus. The Morrison Formation shows signs of seasonal rainfall and periods of drought, suggesting that Allosaurus was adapted to a semi-arid environment with fluctuating water availability. This ability to thrive in varied conditions may have contributed to its success as a species over millions of years. Allosaurus was a formidable predator that roamed North America during the late Jurassic period, about 150 million years ago. When considering its intelligence, we must rely on indirect evidence from fossil remains and comparisons with modern animals. The brain of Allosaurus was relatively large for a dinosaur of its time, suggesting it possessed a degree of cognitive ability that likely surpassed many of its contemporaries. Its brain-to-body size ratio, while not as impressive as some later theropods, was still notable. This indicates that Allosaurus might have been capable of more complex behaviors than many other dinosaurs of its era. Fossil evidence also suggests that Allosaurus had well-developed senses, particularly vision and smell. These acute senses, combined with its relatively large brain, would have made it an effective hunter. It likely had the ability to track prey, anticipate their movements, and potentially even engage in simple problem-solving behaviors. However, it is important to note that dinosaur intelligence should not be directly compared to mammalian intelligence. The structure and function of dinosaur brains were different from those of mammals, and concepts of intelligence can vary widely. While Allosaurus was likely among the more cognitively advanced dinosaurs of its time, it would still be considered less intelligent than many modern animals. Paleontologists have made fascinating discoveries about Allosaurus, a fearsome predator that roamed North America during the late Jurassic period. Evidence from fossil sites suggests that these large theropod dinosaurs might have engaged in some form of social behavior. Bone beds containing multiple Allosaurus specimens of different ages have been uncovered, hinting at the possibility of group living or hunting. This arrangement is similar to what we see in some modern predators, such as wolves or lions. However, it is important to note that interpreting dinosaur behavior from fossils requires careful consideration and often involves some speculation. Tooth marks found on Allosaurus bones indicate that these dinosaurs may have engaged in cannibalism. While this might seem to contradict the idea of social behavior, it could actually support it. In times of scarcity, some social predators today will feed on the remains of their own species. This behavior does not necessarily rule out cooperation in other contexts. The structure of Allosaurus's skull and teeth suggests it was capable of taking down large prey. This fact, combined with evidence of potential group living, has led some researchers to propose that Allosaurus might have hunted in packs. Such cooperative hunting would have allowed them to tackle even larger dinosaurs, like sauropods. However, more evidence is needed to confirm this intriguing possibility about Allosaurus's social dynamics. Allosaurus, the large carnivorous dinosaur that roamed North America during the late Jurassic period, likely engaged in various forms of communication. While we cannot directly observe their behavior, paleontologists have made inferences based on fossil evidence and comparisons with modern animals. One potential form of communication for Allosaurus was visual displays. The dinosaur possessed a pair of horns above its eyes and ridges along its snout. These features may have been used in visual signaling to other members of its species, possibly for territorial displays or mating rituals. The bright colors or patterns on their skin, although not preserved in fossils, could have also played a role in visual communication. Vocalizations were probably another important aspect of Allosaurus communication. Studies of their skull structure suggest they had the ability to produce sounds. These vocalizations might have been used to alert others to the presence of prey, warn of approaching danger, or establish dominance within a group. The exact nature of these sounds remains speculative, but they could have ranged from low-frequency rumbles to higher-pitched calls. Additionally, chemical communication through scent marking was likely part of the Allosaurus behavioral repertoire. Many modern reptiles use pheromones and other chemical signals to communicate information about territory, reproductive status, and individual identity. Allosaurus may have employed similar strategies, leaving scent marks on trees or rocks to convey messages to other members of its species. Allosaurus, the fearsome predator of the late Jurassic period, had a brain that was relatively small compared to its massive body size. This carnivorous dinosaur, which could grow up to 33 feet long and weigh up to 2 tons, possessed a brain that was only about the size of a hot dog. This disparity between brain and body size is common among many dinosaur species, particularly the larger ones. The brain of Allosaurus, while small, was still well developed for its primary functions. It had enlarged olfactory bulbs, indicating a keen sense of smell, which would have been crucial for hunting and tracking prey. The areas of the brain responsible for vision and balance were also well developed, suggesting that Allosaurus was an adept predator with sharp senses. Despite its small size, the Allosaurus brain was sufficient for the dinosaur's survival needs. It allowed for basic problem-solving, sensory processing, and the coordination of complex movements necessary for hunting and daily life. This balance between brain size and body size was typical for large predatory dinosaurs of the time, reflecting an evolutionary trade-off between cognitive capacity and physical power. Comparatively, the brain-to-body ratio of Allosaurus was similar to that of other large theropod dinosaurs like Tyrannosaurus rex. This suggests that these predators relied more on their physical attributes, such as strength and speed, rather than complex cognitive abilities for their survival and dominance in their respective ecosystems. Paleontologists have uncovered several lines of evidence suggesting complex behaviors in Allosaurus, a large theropod dinosaur that lived during the late Jurassic period. Fossil discoveries and careful analysis of skeletal remains have provided insights into how these predators lived and interacted. One key piece of evidence comes from bite marks found on the bones of other dinosaurs. These marks indicate that Allosaurus was an active predator, capable of taking down large prey. The positioning and depth of these bite marks suggest strategic hunting techniques, possibly involving pack behavior or coordinated attacks on larger herbivores. Trackways discovered in various locations have also shed light on Allosaurus behavior. These fossilized footprints show multiple individuals moving in the same direction, hinting at the possibility of group movement or even cooperative hunting strategies. While not conclusive proof of pack behavior, these trackways provide tantalizing clues about social interactions among Allosaurus individuals. Furthermore, studies of Allosaurus brain casts have revealed a relatively large olfactory bulb, suggesting a well-developed sense of smell. This sensory adaptation could have aided in tracking prey over long distances, indicating complex hunting behaviors. Combined with its large eyes and binocular vision, Allosaurus appears to have been a highly capable predator with sophisticated sensory abilities that facilitated complex hunting strategies. Allosaurus, a formidable predator of the late Jurassic period, likely employed sophisticated problem-solving skills during its hunting expeditions. These large theropod dinosaurs faced numerous challenges when pursuing prey, and their success depended on their ability to adapt and strategize. One key aspect of Allosaurus hunting behavior might have involved assessing the vulnerabilities of potential prey. By observing herds of herbivorous dinosaurs, Allosaurus could have identified weaker or isolated individuals, strategically selecting targets that offered the highest chance of a successful hunt. This selective approach would have required the ability to analyze complex social structures and physical conditions within prey groups. Allosaurus may have also demonstrated problem-solving skills through cooperative hunting strategies. Fossil evidence suggests that these predators sometimes hunted in packs, which would have required coordination and communication. This social hunting behavior implies a level of cognitive ability to plan and execute coordinated attacks, adapting tactics based on the specific prey and environmental conditions. Furthermore, Allosaurus likely faced the challenge of tackling prey much larger than itself, such as sauropods. To overcome this size disparity, these predators might have developed techniques to weaken their prey gradually, such as inflicting wounds and then tracking the injured animal over long distances. This persistence hunting method would have demanded patience, stamina, and the ability to predict prey movement patterns, showcasing the complex problem-solving capabilities of these ancient hunters. While direct evidence of play behavior in Allosaurus is limited due to the nature of fossil preservation, paleontologists have made some intriguing observations that suggest these large theropod dinosaurs might have engaged in activities resembling play. Fossil records show that Allosaurus, like many other predatory dinosaurs, lived in social groups. This social structure often correlates with play behavior in modern animals, as it helps develop crucial skills for survival and social interaction. Some fossil sites have revealed multiple Allosaurus specimens of varying ages together, indicating potential family groups or packs. Interestingly, some Allosaurus fossils show healed injuries that could have resulted from interactions with other members of their species. While these injuries might have been from serious fights, they could also indicate rough play or practice combat, similar to what we see in modern predators like lions or wolves. Furthermore, the growth patterns observed in Allosaurus fossils suggest a relatively long period of juvenile development. This extended youth phase could have provided ample opportunity for play behavior to occur, allowing young Allosaurus to hone their hunting and social skills before reaching full adulthood. While we cannot say with absolute certainty that Allosaurus played, the available evidence suggests it was a possibility in their behavioral repertoire. Allosaurus, a fearsome predator of the late Jurassic period, possessed remarkable sensory capabilities that significantly shaped its behavior. Its large eyes, positioned at the front of its skull, provided excellent binocular vision. This depth perception allowed Allosaurus to accurately judge distances, a crucial skill for a predator when pursuing prey or navigating through its environment. The olfactory bulbs in Allosaurus's brain were well developed, indicating a keen sense of smell. This enhanced olfactory ability likely played a vital role in detecting prey, even from considerable distances. Allosaurus could potentially track wounded animals or locate carrion, expanding its feeding opportunities beyond active hunting. Allosaurus also had a sophisticated balance system, as evidenced by its inner ear structure. This gave the dinosaur excellent coordination and agility, enabling it to move swiftly and precisely despite its large size. Such capabilities were essential for successful hunting and survival in the competitive ecosystems of the Jurassic period. These sensory adaptations collectively influenced Allosaurus's behavior, making it an efficient and versatile predator. Its keen senses allowed it to detect and pursue prey effectively, while its agility and coordination enabled it to navigate varied terrains and execute precise attacks. These capabilities likely contributed to Allosaurus's success as one of the dominant predators of its time. Trackways left by Allosaurus provide paleontologists with valuable insights into the behavior of these fearsome Jurassic predators. These fossilized footprints, preserved in ancient sediments, offer a glimpse into how Allosaurus moved and interacted with its environment millions of years ago. One key revelation from Allosaurus trackways is their walking and running gaits. The spacing and arrangement of footprints indicate that these theropods were capable of both slow, deliberate movement and rapid acceleration. This supports the idea that Allosaurus was an active predator, able to stalk prey cautiously and then burst into high-speed pursuit when necessary. Trackways have also shed light on Allosaurus' social behavior. Some sites show multiple sets of footprints moving in the same direction, suggesting that these dinosaurs may have traveled in groups. This finding challenges earlier notions of large theropods as solitary hunters and opens up possibilities of cooperative hunting or other social interactions among Allosaurus individuals. Furthermore, the depth and shape of Allosaurus tracks provide clues about the dinosaur's body posture and weight distribution. These details help paleontologists refine their understanding of Allosaurus anatomy and biomechanics, contributing to more accurate reconstructions of how these prehistoric predators looked and moved in life. Allosaurus, the large carnivorous dinosaur that roamed North America during the late Jurassic period, likely had complex social behaviors beyond hunting. Paleontologists have uncovered evidence suggesting these predators may have engaged in pack behavior, similar to some modern carnivores. This social structure could have facilitated cooperative hunting, allowing Allosaurus to take down larger prey that would have been challenging for a solitary individual. Outside of hunting, Allosaurus might have participated in various social interactions. Fossil evidence indicates potential territorial disputes, as some Allosaurus specimens show injuries consistent with intraspecific combat. These confrontations could have been related to establishing dominance, defending territory, or competing for mates. Juvenile Allosaurus fossils have been found in close proximity to adult remains, hinting at possible parental care or family group structures. This arrangement might have provided protection for young Allosaurus and opportunities for them to learn hunting techniques from more experienced adults. Communication among Allosaurus individuals likely played a crucial role in their social interactions. While we cannot know the exact vocalizations they used, it is plausible that they employed a range of sounds and body language to convey information about threats, food sources, or mating intentions to other members of their species. Allosaurus, one of the most fearsome predators of the late Jurassic period, evolved from earlier theropod dinosaurs. These carnivorous ancestors roamed the Earth millions of years before Allosaurus appeared on the scene. The earliest known ancestors of Allosaurus were small, agile predators that lived during the early to middle Jurassic period. These included dinosaurs like Megalosaurus and Eustreptospondylus, which belonged to a group called megalosauroids. These early theropods were generally smaller than Allosaurus, but shared similar body plans and predatory adaptations. As time progressed, these early theropods gave rise to more specialized hunters. The direct predecessors of Allosaurus likely belonged to a group called Carnosaurs, which included other large predatory dinosaurs. These carnosaurs developed features that would become more pronounced in Allosaurus, such as robust skulls, sharp teeth, and powerful limbs. The exact evolutionary path from these earlier theropods to Allosaurus is still being studied by paleontologists. Fossil evidence suggests a gradual increase in size and refinement of predatory features over millions of years, ultimately culminating in the emergence of Allosaurus as a dominant predator of its time. Allosaurus, a fearsome predator of the late Jurassic period, evolved over millions of years to become one of the most successful large carnivorous dinosaurs of its time. This theropod emerged around 155 million years ago and thrived until about 145 million years ago. The evolution of Allosaurus was marked by several key adaptations that made it a formidable hunter. Its skull developed to be lighter yet stronger, with distinctive crests above the eyes. These crests likely served both for display and to protect the eyes during hunting. The jaws of Allosaurus became more powerful over time, equipped with sharp, serrated teeth that were continually replaced throughout its life. As Allosaurus evolved, its body became more streamlined and efficient. The forelimbs, though short, developed strong muscles and sharp claws, useful for grasping prey. Its powerful hind legs and long tail allowed for quick movements and good balance, making Allosaurus an agile predator despite its large size. Fossil evidence suggests that Allosaurus continued to grow throughout its lifetime, with some individuals reaching lengths of up to 33 feet. This ongoing growth pattern might have been an evolutionary advantage, allowing Allosaurus to compete effectively with other large predators and tackle a variety of prey sizes as it matured. Allosaurus belonged to a group of carnivorous dinosaurs known as theropods, which included many other well-known predators. Among its closest relatives were other large carnivores from the Jurassic period, such as Saurophaganax and Sinraptor. These dinosaurs shared similar body plans and hunting strategies with Allosaurus. Another close relative was Acrocanthosaurus, a slightly younger and larger predator that lived during the early Cretaceous period. This fearsome hunter had a distinctive sail-like structure along its back, setting it apart from its Jurassic cousins. Carcharodontosaurus, a massive predator from North Africa, was also part of the same family as Allosaurus, known as the Allosauridae. Interestingly, the famous Tyrannosaurus rex, while also a theropod, was not as closely related to Allosaurus as one might think. They belonged to different branches of the theropod family tree, with Tyrannosaurus evolving much later in the Cretaceous period. This showcases the diverse evolutionary paths taken by different carnivorous dinosaurs over millions of years. The study of these relationships helps paleontologists understand the evolution and diversity of predatory dinosaurs throughout the Mesozoic era, painting a vivid picture of the complex ecosystems that existed long before humans walked the Earth. Allosaurus, a fearsome predator of the late Jurassic period, played a significant role in shaping the evolution of its prey species. This large theropod dinosaur, with its powerful jaws and sharp teeth, exerted strong selective pressure on the herbivorous dinosaurs that shared its environment. The presence of Allosaurus likely led to the development of more effective defensive mechanisms in its prey. Herbivorous dinosaurs, such as Stegosaurus, evolved elaborate arrays of plates and spikes, which may have served as protection against Allosaurus attacks. Similarly, the long necks of sauropods like Diplodocus might have allowed them to spot approaching predators from a greater distance, giving them more time to flee or prepare for defense. Speed and agility also became crucial factors in survival. Smaller prey species likely evolved to be faster and more maneuverable to evade the powerful but less agile Allosaurus. This predator-prey arms race contributed to the diversity of dinosaur body shapes and sizes we observe in the fossil record. The hunting behavior of Allosaurus may have influenced herd dynamics in its prey species as well. Herbivorous dinosaurs might have developed more complex social structures and behaviors, forming larger herds for increased protection against predators like Allosaurus. This social evolution could have led to more sophisticated communication methods and cooperative defensive strategies among prey species. Allosaurus, a formidable predator of the late Jurassic period, possessed several key evolutionary advantages that set it apart from its contemporaries. This large theropod dinosaur, whose name means different lizard, was a highly successful hunter that dominated its ecosystem for millions of years. One of Allosaurus's most significant advantages was its powerful bite force, enhanced by a unique skull structure. Unlike many other theropods, Allosaurus had a relatively weak bite, but could open its jaws extremely wide. This allowed it to use its head like an axe, slashing into prey with its sharp teeth and upper jaw. This feeding strategy, combined with strong neck muscles, made Allosaurus an efficient killer of large prey. Another advantage was Allosaurus's well-developed sense of smell. Its olfactory bulbs were quite large relative to its brain size, indicating a keen ability to detect prey from a distance. This enhanced sense of smell likely gave Allosaurus an edge in hunting and scavenging, allowing it to locate food sources more effectively than some of its competitors. Allosaurus also benefited from its relatively large size and robust build. While not the largest theropod of its time, it was still an imposing predator, reaching lengths of up to 33 feet. Its strong legs and flexible tail provided both speed and agility, making it a versatile hunter capable of taking down a variety of prey sizes. These adaptations allowed Allosaurus to thrive as a top predator in the diverse ecosystems of the late Jurassic period. Allosaurus was a key player in the evolution of theropod dinosaurs, occupying a significant position in the carnivorous dinosaur lineage during the late Jurassic period, about 150 million years ago. This formidable predator represented an important step in the development of large bipedal carnivores that would eventually lead to the famous Tyrannosaurus rex and other advanced theropods. As a member of the Allosauroidea superfamily, Allosaurus showcased several evolutionary advancements that set it apart from earlier theropods. Its skull was more flexible than its predecessors, with joints that allowed for a wider gape and more efficient bite. This adaptation made Allosaurus a more effective hunter, capable of tackling larger prey. Allosaurus also exhibited changes in limb proportions and overall body plan that would become more pronounced in later theropods. Its arms were shorter relative to its body size compared to earlier carnivorous dinosaurs, a trend that would continue in the evolution of tyrannosaurids. However, Allosaurus retained 3 functional fingers on each hand, unlike the later 2-fingered tyrannosaurids. The success of Allosaurus and its relatives paved the way for the diversification of large theropods in the Cretaceous period. While Allosaurus itself did not leave direct descendants that survived into the late Cretaceous, its evolutionary innovations contributed to the adaptations seen in later theropod groups, making it a crucial link in understanding the evolution of these fascinating prehistoric predators. Birds are the closest living relatives to Allosaurus, a fact that might surprise many people. This connection stems from the evolutionary relationship between dinosaurs and modern avian species. Allosaurus, a large carnivorous dinosaur that lived during the late Jurassic period, about 150 million years ago, belongs to the theropod group of dinosaurs. Theropods are the ancestors of all modern birds. While Allosaurus itself did not directly evolve into birds, it shared a common ancestor with the lineage that eventually led to avian species. This relationship is evident in various anatomical features that Allosaurus and birds share, such as hollow bones, wishbones, and the structure of their hips and legs. These similarities are not coincidental, but the result of millions of years of evolutionary history. Among modern birds, those considered most closely related to Allosaurus are flightless birds like ostriches, emus, and kiwis. These birds, known as ratites, retain more primitive features that link them more closely to their dinosaur ancestors. However, all birds, from hummingbirds to eagles, share this ancestral connection to Allosaurus and other theropod dinosaurs. This evolutionary link between Allosaurus and modern birds offers a fascinating glimpse into the complex history of life on Earth. It demonstrates how species can change dramatically over time, while still retaining traces of their ancient lineage in their genetic makeup and physical characteristics. Allosaurus and Tyrannosaurus rex were both fearsome predators that dominated their respective eras, but their evolutionary paths differed significantly. Allosaurus roamed the Earth during the late Jurassic period, about 150 million years ago, while Tyrannosaurus rex lived much later during the late Cretaceous period, around 66 million years ago. Allosaurus evolved as a swift and agile hunter, with a lighter build and longer arms than its later counterpart. Its skull was designed for slashing attacks, featuring sharp, serrated teeth and a powerful bite force. This hunting strategy was well suited to tackling the large sauropods and other herbivores of its time. Tyrannosaurus rex, on the other hand, evolved to become a massive, powerhouse predator. It developed incredibly strong leg muscles and a robust skull capable of delivering bone-crushing bites. The arms of Tyrannosaurus rex became much smaller over time, possibly to reduce weight and improve balance. Its hunting style likely relied more on ambush tactics and overwhelming force. The evolution of these two theropods reflects the changing environments and prey species of their respective time periods. While Allosaurus was adapted for a world of diverse large herbivores, Tyrannosaurus rex evolved to hunt the heavily armored and horned dinosaurs of the late Cretaceous, showcasing the incredible adaptability of these prehistoric predators. Allosaurus, a formidable predator of the late Jurassic period, evolved under a complex set of pressures that honed its hunting abilities. The need to capture and subdue large prey drove the development of its powerful jaws and sharp, serrated teeth. These features allowed Allosaurus to inflict devastating wounds on its victims, often larger herbivorous dinosaurs. The competitive environment of the Jurassic ecosystem also played a crucial role. Allosaurus had to contend with other large predators, pushing it to develop keen senses and agility. Its eyes, positioned for binocular vision, enhanced depth perception, a vital trait for judging distances when pursuing prey or engaging rivals. Allosaurus also faced pressure to efficiently process its meals. This led to the evolution of a flexible skull that could open wide, allowing it to take large bites and minimize energy expenditure while feeding. The dinosaur's strong neck muscles supported this feeding strategy, enabling powerful strikes and helping to control struggling prey. Climate and habitat changes during the late Jurassic period likely influenced Allosaurus's evolution as well. As environments shifted, the predator had to adapt to new hunting grounds and potentially different prey species, contributing to its success as a dominant carnivore of its time. Allosaurus, a formidable predator of the late Jurassic period, played a crucial role in shaping the ecosystems it inhabited. This large theropod dinosaur, which lived approximately 150 million years ago, evolved to become one of the apex predators of its time, influencing the balance of life in prehistoric North America and Europe. The evolution of Allosaurus brought about significant changes in predator-prey dynamics. As these dinosaurs grew larger and more efficient hunters, they exerted pressure on herbivorous species, potentially driving the evolution of new defensive adaptations in their prey. This evolutionary arms race likely contributed to the diversity of dinosaur species we see in the fossil record from this period. Allosaurus's presence also affected the behavior and distribution of other predators in its environment. Smaller carnivores may have been forced to adapt their hunting strategies or seek out different prey to avoid competition with these powerful hunters. This redistribution of predatory niches could have had cascading effects throughout the ecosystem, influencing the populations and behaviors of various species. Furthermore, as a large predator, Allosaurus would have played a role in controlling herbivore populations, indirectly affecting plant life and landscape ecology. By keeping herbivore numbers in check, these dinosaurs may have influenced the types and distribution of plants that thrived in their habitats, shaping the very foundation of the late Jurassic food web. Allosaurus, one of the most fearsome predators of the Jurassic period, roamed the Earth approximately 150 million years ago. This massive carnivore, with its sharp teeth and powerful jaws, dominated the landscape for millions of years before its eventual extinction. The exact timing of the Allosaurus extinction is a subject of ongoing research and debate among paleontologists. However, current evidence suggests that Allosaurus disappeared from the fossil record around 145 million years ago, near the end of the Jurassic period. This places their extinction just before the transition into the Cretaceous period, a time of significant changes in Earth's climate and ecosystems. The reasons for the Allosaurus extinction remain uncertain, but scientists have proposed several theories. These include changes in the global climate, shifts in vegetation that affected their prey species, and competition from newly evolving dinosaur species. It is likely that a combination of these factors contributed to the decline and eventual disappearance of Allosaurus. Despite its extinction, Allosaurus left a lasting impact on the evolution of large, predatory dinosaurs. Its legacy can be seen in the adaptations of later theropod dinosaurs, showcasing the ongoing process of evolution and extinction that has shaped life on Earth for millions of years. Allosaurus, a fearsome predator of the late Jurassic period, faced several challenges that ultimately led to its extinction. Climate change played a significant role, as the warm, humid conditions of the Jurassic gave way to cooler and drier weather. This shift altered the vegetation and, consequently, the herbivorous dinosaur populations that Allosaurus relied on for food. Competition from other predators also contributed to the decline of Allosaurus. As new carnivorous species evolved, they competed for the same prey and territory. Some of these new predators may have been better adapted to the changing environment, giving them an edge over Allosaurus. Changes in the Earth's geography further impacted Allosaurus populations. The breakup of the supercontinent Pangaea created new barriers and isolated different groups of dinosaurs. This fragmentation of habitats made it more difficult for Allosaurus to maintain large, sustainable populations across wide areas. Disease and other environmental factors likely played a role as well. Paleontologists have found evidence of injuries and infections in Allosaurus fossils, suggesting that these powerful hunters were vulnerable to various health issues. As their numbers dwindled due to other pressures, they became more susceptible to localized extinctions from diseases or environmental disasters. Allosaurus, a fearsome predator of the late Jurassic period, vanished from the fossil record approximately 70 million years before the mass extinction event that marked the end of the dinosaur era. This powerful carnivore roamed the Earth between 155 million and 145 million years ago, during a time when the continents were still joined as the supercontinent Pangaea. The mass extinction event, known as the Cretaceous-Paleogene extinction, occurred about 66 million years ago. This catastrophic event wiped out approximately 75% of plant and animal species on Earth, including the remaining non-avian dinosaurs. However, Allosaurus had long since disappeared by this point, having lived and thrived in a much earlier period of Earth's history. The disappearance of Allosaurus was not directly related to the mass extinction event that would later claim its dinosaur relatives. Instead, it was likely due to changes in climate, competition from other predators, or shifts in the available prey species. The long gap between the extinction of Allosaurus and the end Cretaceous event underscores the vast spans of time involved in dinosaur evolution and extinction. This significant time difference also highlights the diversity and longevity of the dinosaur reign on Earth. Many dinosaur species came and went over millions of years, each adapting to and thriving in their specific environmental niches long before the final extinction event that would end the age of dinosaurs. The fossil record provides us with intriguing glimpses into the final years of Allosaurus, a fearsome predator that roamed North America during the late Jurassic period. Paleontologists have uncovered numerous Allosaurus remains from the Morrison Formation, a rich fossil bed spanning several states in the western United States. These fossils, dating back to approximately 150 million years ago, offer valuable insights into the life and times of this apex predator. One of the most compelling pieces of evidence comes from a site in Wyoming, where researchers discovered an Allosaurus specimen with a severe injury to its neck vertebrae. This injury, likely sustained during a violent encounter with prey or another predator, had partially healed, indicating that the animal survived for some time after the incident. Such findings suggest that Allosaurus faced significant challenges and intense competition in its environment during its final years. Additionally, studies of Allosaurus teeth and jaw mechanics have revealed adaptations for crushing bone, implying that these dinosaurs may have evolved more specialized feeding strategies as they approached the end of their reign. This could indicate changes in prey availability or increased competition from other predators, forcing Allosaurus to adapt its hunting and feeding behaviors. Curiously, the fossil record shows a decline in Allosaurus remains towards the end of the Jurassic period, coinciding with environmental changes and the rise of new dinosaur species. This gradual disappearance from the fossil record hints at the challenges these magnificent predators faced in their final years, as they struggled to adapt to a changing world that would eventually see their extinction. Allosaurus, a fearsome predator of the late Jurassic period, did not face extinction at the same time as many other well-known dinosaur species. This large theropod dinosaur vanished from the fossil record approximately 150 million years ago, long before the mass extinction event that claimed most dinosaur species at the end of the Cretaceous period. The disappearance of Allosaurus occurred during a time of significant environmental and ecological changes. As the Jurassic period transitioned into the Cretaceous, sea levels fluctuated, climates shifted, a new dinosaur species emerged. Allosaurus and its close relatives were gradually replaced by other large predatory dinosaurs, including the rise of tyrannosaurs in the northern continents. While Allosaurus did not survive to see the end Cretaceous extinction that wiped out most dinosaur species 66 million years ago, its legacy lived on through its descendants and relatives. Some of these animals, like Carcharodontosaurus and Giganotosaurus, evolved to become even larger and more formidable predators in the ecosystems of the Cretaceous period. The story of Allosaurus reminds us that extinction is a constant process in the history of life on Earth, not just confined to catastrophic events. Species come and go over time, shaped by changing environments, competition, and the endless dance of evolution. Climate change played a significant role in the fate of Allosaurus, a formidable predator that roamed North America during the late Jurassic period. As the Jurassic transitioned into the Cretaceous approximately 145 million years ago, the Earth experienced notable shifts in temperature and humidity. These alterations in climate led to changes in vegetation, which in turn affected the herbivorous dinosaurs that Allosaurus preyed upon. As plant life adapted to new conditions, some herbivore species struggled to find suitable food sources, causing fluctuations in their populations. This directly impacted Allosaurus, as its primary food supply became less reliable. Furthermore, the changing climate influenced the availability of water sources. Periods of increased aridity made certain regions less habitable for both Allosaurus and its prey. This forced dinosaur populations to migrate or adapt, putting additional stress on the ecosystem and potentially leading to increased competition for resources. The climate shifts also affected the hatching success and survival rates of Allosaurus offspring. Changes in temperature and humidity could have made it more challenging for eggs to develop properly, or for young Allosaurus to thrive in their early stages of life. These factors, combined with increased competition and changing prey dynamics, ultimately contributed to the decline of Allosaurus populations over time. Allosaurus, the fearsome predator of the late Jurassic period, faced numerous challenges that ultimately led to its extinction. Competition played a significant role in this process, though it was not the sole factor. As the Jurassic period transitioned into the Cretaceous, the ecosystem underwent dramatic changes, bringing new predators and prey into Allosaurus's domain. One of the main competitors that emerged was Acrocanthosaurus, a large theropod dinosaur that occupied a similar ecological niche. This new predator was better adapted to hunting the evolving herbivorous dinosaurs of the early Cretaceous, potentially outcompeting Allosaurus for food resources. Additionally, smaller, more agile theropods like Deinonychus began to proliferate, occupying different hunting strategies and further increasing competition for prey. Climate change also played a crucial role in altering the landscape and vegetation, which in turn affected the herbivorous dinosaurs that Allosaurus preyed upon. As these prey species adapted or were replaced by new forms, Allosaurus found itself less suited to hunting in the changing environment. This gave an advantage to predators that could more readily adapt to the new conditions and prey types. The combination of increased competition, changing prey dynamics, and environmental shifts created a perfect storm that Allosaurus could not overcome. While competition was a significant factor, it was the interplay of multiple pressures that ultimately led to the extinction of this once dominant predator, making way for new species to rise and thrive in the evolving Cretaceous world. Allosaurus, a formidable predator of the late Jurassic period, possessed several specialized hunting adaptations that contributed to its success and survival. Its powerful jaws were lined with sharp, serrated teeth, ideal for slicing through the flesh of its prey. These teeth, combined with a strong bite force, allowed Allosaurus to inflict devastating wounds on its victims. The theropod's skull was remarkably flexible, featuring joints that allowed it to open its mouth extremely wide. This adaptation enabled Allosaurus to deliver powerful, axe-like bites, effectively using its upper jaw as a weapon to weaken larger prey. Such a hunting strategy proved particularly effective against the giant sauropods that shared its environment. Allosaurus also boasted strong legs and a relatively lightweight build, granting it impressive speed and agility for its size. These features allowed it to pursue a variety of prey and adapt to different hunting scenarios. Its well-developed sense of smell and binocular vision further enhanced its predatory capabilities, making it a highly efficient hunter. These adaptations collectively enabled Allosaurus to thrive in diverse environments and adapt to changing conditions. Its versatile hunting strategies and ability to take down both large and small prey likely contributed to its survival during periods of ecological change, allowing it to persist for millions of years as one of the dominant predators of its time. The extinction of Allosaurus, a large carnivorous dinosaur that lived during the late Jurassic period, offers valuable insights into ecosystem stability and the complex interplay of factors that can lead to species collapse. Allosaurus was a dominant predator in its environment, occupying a crucial role at the top of the food chain. Its disappearance would have had far-reaching consequences throughout the ecosystem. The demise of Allosaurus likely created a ripple effect, altering predator-prey relationships and potentially allowing other species to fill the vacant ecological niche. This shift demonstrates the delicate balance within ecosystems and how the loss of a key species can trigger cascading changes. The extinction event that claimed Allosaurus also affected numerous other species, highlighting the interconnectedness of life forms within a given environment. Studying the Allosaurus extinction provides clues about the vulnerability of apex predators to environmental changes. Large carnivores often require extensive territories and substantial prey populations to survive, making them particularly susceptible to habitat disruptions or climate fluctuations. The fate of Allosaurus serves as a reminder that even seemingly dominant species can falter when faced with significant environmental challenges. Furthermore, the Allosaurus extinction underscores the importance of biodiversity in maintaining ecosystem resilience. When a major predator disappears, it can lead to overpopulation of prey species, altering vegetation patterns and impacting other organisms throughout the food web. This example from the distant past offers valuable lessons for understanding and protecting modern ecosystems, emphasizing the need to preserve biodiversity to maintain ecological stability in the face of environmental changes. The extinction of Allosaurus, a fearsome predator that roamed the Earth during the late Jurassic period, offers valuable insights into modern extinction events. This large theropod dinosaur vanished from the fossil record about 150 million years ago, long before the mass extinction that wiped out most dinosaurs at the end of the Cretaceous period. Studying the demise of Allosaurus helps scientists understand how changes in climate, habitat, and food chains can lead to the downfall of even apex predators. The gradual decline of Allosaurus populations over time, rather than a sudden disappearance, mirrors many modern extinction patterns. This gradual process highlights the importance of monitoring population trends and ecosystem health in contemporary conservation efforts. Furthermore, the extinction of Allosaurus emphasizes the interconnectedness of species within ecosystems. As a top predator, its disappearance likely had ripple effects throughout the food web, altering the balance of prey species and potentially affecting plant life. This understanding reinforces the concept of keystone species in modern ecosystems and the far-reaching consequences of their loss. By examining the factors that contributed to Allosaurus's extinction, such as changes in prey availability or shifts in climate, scientists can better predict and potentially mitigate similar threats to modern species. This knowledge is crucial for developing effective conservation strategies and understanding the complex dynamics of extinction in our rapidly changing world. Paleontologists employ a variety of sophisticated techniques to study Allosaurus fossils, shedding light on this fearsome predator from the late Jurassic period. One key method is careful excavation, where scientists meticulously unearth bones and preserve their position in the rock layers. This process helps reconstruct the dinosaur's posture and environment. Once extracted, the fossils undergo detailed examination. Scientists use advanced imaging technologies, such as computed tomography scans, to peer inside the bones without damaging them. These scans reveal internal structures, providing insights into the Allosaurus's growth patterns, potential injuries, and even its brain cavity shape. Chemical analysis of the fossilized bones offers another avenue of study. By examining trace elements and isotopes, researchers can infer details about the Allosaurus's diet and the climate it lived in. This information helps paint a more complete picture of the ecosystem these predators inhabited. Comparative studies also play a crucial role. Scientists compare Allosaurus fossils to those of related species and modern animals. This approach allows them to make informed hypotheses about the dinosaurs' muscle attachments, movement capabilities, and evolutionary relationships. Through these diverse techniques, paleontologists continue to unravel the mysteries of Allosaurus and its ancient world. Scientists face significant challenges when determining the coloration of extinct creatures like Allosaurus, a large carnivorous dinosaur that lived during the late Jurassic period. Unlike with modern animals, researchers cannot directly observe the colors of these ancient predators. However, they employ several innovative techniques to make educated guesses about dinosaur coloration. One method involves analyzing fossilized pigment cells called melanosomes. These microscopic structures, when preserved in fossils, can provide clues about the original colors of dinosaur skin and feathers. By comparing the shape and size of these melanosomes to those found in modern animals, scientists can infer potential colors and patterns. Another approach examines the chemical composition of fossils. Certain elements, such as copper, can indicate the presence of specific pigments. Advanced imaging techniques like synchrotron rapid scanning X-ray fluorescence allow researchers to detect trace elements in fossils that might correspond to different colors. Scientists also consider the habitats and lifestyles of dinosaurs like Allosaurus when hypothesizing about their coloration. They look at modern animals in similar ecological niches for inspiration. For instance, large predators in open environments often have colors that provide camouflage, which might suggest that Allosaurus had earth tones or mottled patterns to blend with its surroundings. Technology has revolutionized our understanding of Allosaurus, the fearsome predator that roamed North America during the late Jurassic period. Advanced imaging techniques, such as computed tomography scans, allow paleontologists to peer inside fossilized Allosaurus bones without damaging them. These scans reveal intricate details about the dinosaur's anatomy, including its brain structure and sensory capabilities. Three-dimensional modeling software enables researchers to reconstruct Allosaurus skeletons digitally, providing insights into its movement and behavior. By simulating muscle attachments and joint articulations, scientists can estimate how this massive carnivore walked, ran, and hunted its prey. This technology has challenged previous assumptions about Allosaurus agility and hunting strategies. Geochemical analysis tools have become invaluable in studying Allosaurus fossils. By examining trace elements and isotopes in fossilized teeth and bones, researchers can deduce information about the dinosaur's diet, habitat, and even climate conditions during its lifetime. This data helps paint a more comprehensive picture of the Allosaurus ecosystem. Advances in genetic sequencing have opened new avenues for Allosaurus research. While extracting DNA from fossils millions of years old remains challenging, scientists have successfully isolated and analyzed proteins from Allosaurus bones. These ancient molecules provide clues about the evolutionary relationships between Allosaurus and other theropod dinosaurs, as well as modern birds. Paleontologists use a variety of techniques to estimate the muscle mass and appearance of Allosaurus, a large carnivorous dinosaur from the late Jurassic period. They begin by studying the fossilized bones, paying close attention to muscle attachment points called rugosities. These rough areas on the bones indicate where muscles were once anchored, providing clues about their size and arrangement. Comparisons with modern animals, particularly birds and crocodiles, which are the closest living relatives of dinosaurs, also play a crucial role. By examining how muscles attach to bones in these contemporary creatures, scientists can make informed inferences about Allosaurus anatomy. This method, known as comparative anatomy, helps create a more accurate picture of the dinosaur musculature. Advanced technology has revolutionized the field of paleontology. Computer modeling and three-dimensional scanning of Allosaurus fossils allow researchers to digitally reconstruct the skeleton and simulate muscle placement. These models can even test different muscle configurations to determine which arrangements would have been most efficient for movement and hunting. Fossilized skin impressions, though rare, provide valuable information about the external appearance of dinosaurs. While no such impressions have been found for Allosaurus specifically, those from related species help inform educated guesses about its skin texture and covering. By combining all these methods, paleontologists can create a reasonably accurate representation of how Allosaurus might have looked and moved in life, though some aspects remain open to interpretation and ongoing research. Computed tomography scans of Allosaurus fossils provide paleontologists with remarkable insights into the anatomy and lifestyle of these fearsome Jurassic predators. These advanced imaging techniques allow scientists to peer inside fossilized bones and teeth without damaging the precious specimens. By examining CT scans, researchers can study the internal structure of Allosaurus skulls, revealing details about their sensory capabilities. The scans show the shape and size of brain cavities, providing clues about the dinosaur's intelligence and sensory acuity. They also illuminate the structure of nasal passages and inner ear canals, offering insights into the Allosaurus's sense of smell and balance. CT scans of Allosaurus teeth and jaws have been particularly illuminating. They reveal growth rings within the teeth, similar to tree rings, allowing scientists to estimate the age and growth rate of individual animals. The scans also show how replacement teeth developed within the jaw, ready to emerge when older teeth fell out. Furthermore, CT imaging of limb bones can reveal information about the Allosaurus's movement and hunting behavior. By analyzing the internal bone structure, researchers can estimate the dinosaur's weight and muscle attachment points, helping to reconstruct its posture and gait. This technology continues to unveil new details about these ancient predators, enhancing our understanding of life in the Jurassic period. Scientists employ a variety of techniques to study the biomechanics of Allosaurus movement, combining modern technology with traditional paleontological methods. They start by examining fossilized Allosaurus bones, paying close attention to muscle attachment points, joint structures, and overall skeletal anatomy. This provides a foundation for understanding the dinosaur's potential range of motion and physical capabilities. Computer modeling plays a crucial role in this research. Scientists create detailed digital reconstructions of Allosaurus skeletons, which they can manipulate to test different movement hypotheses. These models allow researchers to simulate various gaits, running speeds, and hunting behaviors, providing insights into how the dinosaur might have moved in its environment. Comparative studies with modern animals also contribute to our understanding of Allosaurus biomechanics. By examining the movement patterns of large predatory birds and crocodilians, scientists can draw parallels to help inform their theories about dinosaur locomotion. This approach helps bridge the gap between ancient fossils and living creatures, offering valuable context for interpretation. Interdisciplinary collaboration further enhances these studies. Paleontologists work alongside biomechanics experts, computer scientists, and even roboticists to create comprehensive analyses of Allosaurus movement. Some researchers have even constructed robotic models to test theories about dinosaur locomotion in the physical world, providing tangible data to complement digital simulations. Scientists employ various techniques to uncover the sensory abilities of Allosaurus, a fearsome predator that roamed the Earth during the late Jurassic period. One key method involves studying fossilized skull remains, particularly the areas where sensory organs were located. By examining the size and shape of the olfactory bulbs, researchers can estimate the dinosaur's sense of smell. Paleontologists also analyze the eye socket size and brain case structure to infer visual acuity and overall sensory processing capabilities. Computer tomography scans of well-preserved Allosaurus skulls provide detailed three-dimensional models, allowing scientists to study the inner ear structure. This information offers insights into the dinosaur's balance and hearing abilities. Comparisons with modern animals, especially birds and crocodiles, which are the closest living relatives of dinosaurs, help researchers make educated guesses about Allosaurus' sensory capabilities. By studying the sensory systems of these contemporary creatures, scientists can draw parallels and make inferences about how Allosaurus might have perceived its environment. Trace fossil evidence, such as footprints and feeding sites, also contributes to our understanding of Allosaurus behavior and sensory abilities. These preserved traces of activity can indicate how the dinosaur interacted with its surroundings, providing clues about its sensory strengths and limitations. Paleontologists use a variety of methods to reconstruct the ecosystem of Allosaurus, a large carnivorous dinosaur that lived during the late Jurassic period. They start by examining the fossil remains of Allosaurus itself, studying its bones, teeth, and any preserved soft tissues to understand its physical characteristics and potential behaviors. But reconstructing an ecosystem involves much more than just studying a single species. Scientists analyze the sediments and rock layers where Allosaurus fossils are found, which provide clues about the ancient environment. They look for evidence of plants, other animals, and even microscopic organisms that lived alongside Allosaurus. Fossil plants are particularly important in ecosystem reconstruction. By identifying the types of plants that grew during the time of Allosaurus, paleontologists can determine the climate and landscape of the region. They might find evidence of lush forests, open plains, or a mix of different habitats. Other animal fossils found in the same rock formations as Allosaurus help scientists understand the food web and ecological relationships of the time. This includes potential prey animals, competitors, and smaller organisms that form the base of the food chain. By piecing together all this evidence, paleontologists can create a comprehensive picture of the world in which Allosaurus lived and hunted. Researchers studying Allosaurus face several intriguing challenges that stem from the nature of fossil evidence and the vast span of time separating us from these ancient predators. One significant hurdle is the fragmentary nature of many Allosaurus fossils. While some well-preserved specimens exist, many are incomplete, making it difficult to fully understand the dinosaur's anatomy and variations within the species. Another challenge lies in interpreting the behavior and lifestyle of Allosaurus from fossilized remains. Scientists must carefully analyze bone structure, tooth marks, and other subtle clues to piece together how these carnivores lived and hunted. This process requires meticulous examination and often leads to ongoing debates within the paleontological community. The geological context of Allosaurus fossils also presents challenges. Researchers must accurately date the fossils and understand the environmental conditions of the late Jurassic period. This involves studying not just the dinosaur remains, but also the surrounding rock formations and other fossils found in the same layers. Distinguishing Allosaurus from other large theropod dinosaurs can be complex, especially when dealing with incomplete specimens. This challenge has led to discussions about the number of Allosaurus species and their relationships to other carnivorous dinosaurs of the time. Despite these obstacles, ongoing research continues to unveil new insights into the life and times of this fascinating predator from the distant past. Recent advancements in paleontological techniques have significantly enhanced our understanding of Allosaurus, the formidable predator that roamed North America during the late Jurassic period. Modern imaging technologies, such as computed tomography scans, have allowed scientists to peer inside fossilized Allosaurus skulls, revealing intricate details about their sensory capabilities and brain structure. These new methods have shown that Allosaurus possessed a more sophisticated sense of smell than previously thought, with enlarged olfactory bulbs that likely aided in tracking prey across vast distances. Additionally, analysis of microscopic tooth-wear patterns has provided insights into the feeding behavior of Allosaurus, suggesting it was an active predator capable of tackling large prey rather than primarily a scavenger, as some had speculated. Biomechanical studies utilizing three-dimensional computer models have shed light on the locomotion and hunting strategies of Allosaurus. These analyses indicate that despite its large size, Allosaurus was a remarkably agile predator, capable of quick turns and rapid acceleration. This agility, combined with its powerful jaws and sharp teeth, made Allosaurus a highly effective hunter in the Jurassic ecosystem. Furthermore, new fossil discoveries and improved dating techniques have expanded our knowledge of Allosaurus diversity and evolution. Scientists now recognize several distinct species within the Allosaurus genus, each adapted to slightly different environments and time periods. This diversity highlights the success and adaptability of these theropod dinosaurs, painting a more complex picture of their role in Jurassic food webs and their evolutionary history. Allosaurus fossils have been discovered across several continents, revealing the widespread distribution of this fearsome predator during the late Jurassic period. North America has yielded the most abundant and well-preserved Allosaurus remains, with numerous fossils unearthed in the western United States, particularly in states like Utah, Colorado, and Wyoming. These findings have provided paleontologists with a wealth of information about the anatomy and behavior of this iconic dinosaur. Europe has also produced significant Allosaurus discoveries, with fossils found in Portugal and possibly France. These European specimens have sparked debates among scientists about the potential differences between North American and European Allosaurus populations, leading to discussions about species variation and evolutionary adaptations. Intriguingly, Allosaurus fossils have been reported from Africa as well, specifically in Tanzania. While these African fossils are more fragmentary and less numerous than their North American counterparts, they offer tantalizing glimpses into the potential global range of Allosaurus or closely related species. Some paleontologists have even suggested possible Allosaurus remains in Australia, though these findings remain controversial and require further study for confirmation. The distribution of Allosaurus fossils across multiple continents provides valuable insights into the paleogeography of the late Jurassic world, hinting at possible land connections or dispersal routes that allowed these large predators to spread across vast distances. This global presence underscores the success and adaptability of Allosaurus as a dominant carnivore in diverse ecosystems millions of years ago. Allosaurus, a fearsome predator of the late Jurassic period, showed notable differences between regions, reflecting adaptations to diverse environments and prey. In North America, particularly in the Morrison Formation, Allosaurus fragilis was the dominant species. These animals were robust, reaching lengths of up to 30 feet and weighing over 2 tons. They possess strong, serrated teeth and powerful limbs, perfectly suited for hunting large sauropods and other herbivores that roamed the lush Jurassic landscapes. In contrast, European Allosaurus species, such as Allosaurus europaeus discovered in Portugal, were generally smaller and more lightly built than their American counterparts. This size difference likely reflected the different prey available in the European ecosystems of the time. The European Allosaurus also showed subtle variations in skull structure and tooth arrangement, possibly indicating a diet that included a wider variety of smaller prey. Fossil evidence from Africa and Australia suggests the presence of Allosaurus-like theropods in these regions as well. However, these fossils are more fragmentary, making it challenging to determine if they represent true Allosaurus species or closely related genera. The African specimens, for instance, show some similarities to Allosaurus, but also possess unique features that might place them in a separate but related group. These regional differences in Allosaurus species highlight the incredible adaptability of these prehistoric predators. As they spread across different continents, they evolved to suit local conditions, resulting in a diverse array of Allosaurus forms across the globe. This variation not only showcases the evolutionary process in action, but also provides valuable insights into the different ecosystems that existed during the late Jurassic period. Paleontologists have uncovered intriguing evidence suggesting that Allosaurus, the formidable Jurassic predator, might have engaged in seasonal migrations. Fossilized tooth marks on herbivore bones found in different geological formations indicate that Allosaurus did not confine itself to a single territory. These tooth marks, matching the distinctive dental pattern of Allosaurus, have been discovered in locations separated by hundreds of miles, hinting at the possibility of long-distance movement. Further supporting this hypothesis are studies of bone histology in Allosaurus fossils. By examining the microscopic structure of these ancient bones, scientists have identified growth patterns that suggest periodic changes in diet and environmental conditions. These changes align with what we might expect to see in an animal that moves between different habitats throughout the year. Trace element analysis of Allosaurus teeth has also provided valuable insights. Variations in the chemical composition of tooth enamel from specimens found in different locations suggest that these animals were consuming prey from diverse ecosystems. This data points to the likelihood that Allosaurus populations were not stationary but moved across substantial distances, possibly following herds of herbivorous dinosaurs. While the evidence is not yet conclusive, these findings collectively paint a picture of Allosaurus as a potentially migratory species. This behavior would have allowed these predators to exploit seasonal food sources and adapt to changing environmental conditions, showcasing the complex ecological dynamics of the Jurassic period. Allosaurus roamed the Earth during the late Jurassic period, approximately 150 million years ago. This fearsome predator was one of the most common large carnivorous dinosaurs of its time, with fossils discovered across a wide geographic range. Evidence of Allosaurus has been found primarily in North America, particularly in the western United States. The Morrison Formation, a vast expanse of sedimentary rock stretching from New Mexico to Montana, has yielded numerous Allosaurus specimens. This suggests the dinosaur was well adapted to the diverse environments of prehistoric North America. Beyond North America, Allosaurus fossils have also been unearthed in Europe, specifically in Portugal. Some paleontologists argue that similar fossils found in Africa and Australia might belong to Allosaurus or closely related species, though these claims remain debated in the scientific community. The widespread distribution of Allosaurus fossils indicates that this dinosaur was highly successful in its ecological niche. Its ability to thrive across different regions speaks to its adaptability and effectiveness as a predator in the late Jurassic ecosystem. Allosaurus, the formidable predator of the late Jurassic period, was primarily known from fossil discoveries in North America, particularly in the western United States. However, evidence suggests that Allosaurus or closely related species might have existed beyond the main continent, potentially including island habitats. Fossil remains attributed to Allosaurus have been found in Portugal, which during the late Jurassic was part of an island archipelago. This discovery hints at the possibility that Allosaurus or its close relatives could have inhabited island environments. These European Allosaurus fossils, while similar to their North American counterparts, show some distinct features, leading some paleontologists to consider them a separate species. The concept of island-dwelling Allosaurus populations opens up intriguing questions about their adaptation and evolution. Islands often lead to unique evolutionary paths for their inhabitants, potentially resulting in changes in size, behavior, or physical characteristics. However, given the limited fossil evidence, it is challenging to draw definitive conclusions about how these island-dwelling Allosaurus might have differed from their mainland relatives. It is worth noting that during the Jurassic period, the arrangement of landmasses was quite different from today, with various islands and archipelagos existing where we now find continents. This dynamic geography could have provided opportunities for Allosaurus to spread to and inhabit various island environments, contributing to their wide distribution and potential diversification. Allosaurus, one of the most fearsome predators of the late Jurassic period, evolved distinct regional variations across its range. These differences were primarily influenced by the unique environmental conditions and prey availability in different areas. In North America, where Allosaurus fossils are most abundant, we see evidence of larger, more robust individuals. This could be attributed to the presence of large sauropod dinosaurs, which would have required formidable predators to hunt them. The North American Allosaurus developed stronger jaw muscles and more robust teeth to tackle these massive prey items. Conversely, Allosaurus fossils found in Europe tend to be slightly smaller and more lightly built. This suggests that European Allosaurus may have adapted to hunt swifter, more agile prey. The different prey base likely led to changes in hunting strategies and physical adaptations over time. Interestingly, recent discoveries in Australia have revealed Allosaurus fossils with unique features not seen in their Northern Hemisphere counterparts. These differences highlight how geographic isolation can lead to divergent evolution even within the same genus. The Australian Allosaurus appears to have developed specialized adaptations to suit the unique fauna and environmental conditions of the southern continent during the Jurassic period. The distribution of Allosaurus fossils provides valuable insights into the geography and climate of Earth during the late Jurassic period, approximately 150 million years ago. Allosaurus was a large carnivorous dinosaur that roamed across what is now North America, Europe, and Africa. The widespread presence of these fossils suggests that these continents were once connected, forming the supercontinent Pangaea. Allosaurus remains have been discovered primarily in rock formations from the Morrison Formation in the western United States, with notable finds in Colorado, Utah, and Wyoming. However, similar fossils have also been unearthed in Portugal and Tanzania. This distribution pattern indicates that Allosaurus or closely related species were able to move freely across vast distances, implying the existence of land bridges between these now separate continents. The fossil evidence also sheds light on the environmental conditions of the time. Allosaurus thrived in semi-arid environments with seasonal rainfall, suggesting that much of Pangaea experienced this climate type. The abundance of Allosaurus fossils in certain areas points to ecosystems capable of supporting large predators, implying the presence of diverse plant and herbivorous dinosaur populations. By studying the subtle differences in Allosaurus fossils from different locations, paleontologists can trace the gradual separation of continents and the evolution of distinct species. This information contributes to our understanding of plate tectonics and the dynamic nature of Earth's geography over millions of years. Allosaurus, a formidable predator of the late Jurassic period, demonstrated remarkable adaptability to various regional environments across what is now North America and Europe. This large theropod dinosaur evolved specific traits that allowed it to thrive in diverse habitats, from coastal plains to inland forests. One key adaptation was Allosaurus's powerful legs and agile body, which enabled it to navigate different terrains effectively. In more open environments, these features allowed for swift pursuit of prey, while in densely forested areas, Allosaurus could maneuver between trees with surprising dexterity for its size. The skull of Allosaurus also showed adaptations to different prey types found in various regions. Its strong jaws and serrated teeth were versatile enough to handle a wide range of prey sizes, from smaller dinosaurs to larger sauropods. This adaptability in feeding strategies allowed Allosaurus to occupy the role of apex predator in multiple ecosystems. Fossil evidence suggests that Allosaurus may have also adapted its hunting behavior to suit different environments. In some regions, there are indications of pack hunting, which would have been advantageous in taking down larger prey. In other areas, fossils point to more solitary hunting styles, demonstrating the species' flexibility in social behavior based on environmental demands. Allosaurus, a fearsome carnivore of the late Jurassic period, shared its environment with several other predatory dinosaurs across different regions. In North America, where Allosaurus was most prevalent, it competed with the smaller but agile Ceratosaurus. This horned predator, though not as large as Allosaurus, was still a formidable hunter that likely targeted similar prey. Another significant competitor was Torvosaurus, a large theropod that rivaled Allosaurus in size. Fossil evidence suggests that these two giants might have occasionally clashed over territory and food sources. In some areas, Allosaurus also faced competition from the unusual Stokesaurus, a smaller carnivore that was an early relative of the famous Tyrannosaurus rex. In Europe, where some Allosaurus fossils have been found, it might have encountered predators like Metriacanthosaurus, a medium-sized carnivore with a distinctive sail-like structure on its back. This diversity of predators in different regions meant that Allosaurus had to be adaptable and efficient in its hunting strategies to maintain its position in the food chain. The presence of these various predators in the same ecosystems as Allosaurus highlights the complex and competitive nature of the Jurassic period. Each of these carnivores likely carved out specific niches, targeting different prey or hunting in distinct habitats to coexist in these ancient environments. Allosaurus, a formidable predator of the late Jurassic period, had a diverse diet that varied depending on its habitat and the available prey. In the Morrison Formation of North America, where Allosaurus fossils are most commonly found, these carnivores likely preyed on a range of herbivorous dinosaurs. In areas with abundant sauropods, such as Diplodocus and Apatosaurus, Allosaurus might have targeted juveniles or worked in groups to bring down these massive creatures. Evidence suggests they may have used their serrated teeth to inflict deep, bleeding wounds on larger prey, then followed them until they succumbed to blood loss and exhaustion. In regions where smaller herbivores were more common, Allosaurus would have hunted ornithopods like Camptosaurus and Dryosaurus. These more agile prey would have required different hunting strategies, possibly involving ambush tactics or chasing them down with their powerful legs. Fossil evidence also indicates that Allosaurus did not shy away from hunting armored prey like Stegosaurus in areas where these animals were prevalent. This suggests that Allosaurus was an adaptable predator, capable of modifying its hunting techniques based on the available prey in different ecosystems within its range. Studying Allosaurus provides valuable insights into the evolution of large predatory dinosaurs and the broader development of theropods. This carnivorous dinosaur, which lived during the late Jurassic period about 150 million years ago, offers paleontologists a window into the adaptations and characteristics that would later influence the evolution of other large predators, including Tyrannosaurus rex. Allosaurus fossils reveal important information about the development of physical features crucial for predation. Its skull structure, with lightweight bones and large fenestrae, demonstrates an early example of the balance between strength and weight reduction that became even more pronounced in later theropods. The sharp, serrated teeth of Allosaurus show the refinement of carnivorous dental adaptations, a trait that continued to evolve in subsequent predatory dinosaurs. The study of Allosaurus also contributes to our understanding of dinosaur behavior and ecology. Evidence suggests that Allosaurus may have hunted in groups, providing clues about the social behavior of large predators. This information helps paleontologists reconstruct ancient ecosystems and food webs, shedding light on the complex interactions between different dinosaur species. Furthermore, the widespread distribution of Allosaurus fossils across North America, Europe, and Africa offers insights into dinosaur migration patterns and the geographical spread of species during the Jurassic period. This data is crucial for understanding how dinosaurs adapted to different environments and how their evolution was influenced by changing climates and shifting continents. Allosaurus, the apex predator of the late Jurassic period, offers valuable insights into modern ecosystem dynamics. This formidable carnivore, which roamed North America about 150 million years ago, played a crucial role in shaping its environment, much like top predators do today. By studying Allosaurus, we can better understand the importance of apex predators in maintaining ecological balance. These dinosaurs likely controlled herbivore populations, preventing overgrazing and promoting plant diversity. This relationship mirrors the impact of modern predators like wolves or lions on their respective ecosystems. Fossil evidence suggests Allosaurus engaged in pack hunting, a behavior seen in some contemporary predators. This cooperative strategy allowed them to take down larger prey, influencing the evolution of defensive mechanisms in herbivorous dinosaurs. Similarly, modern prey species have developed various adaptations in response to predation pressure. The study of Allosaurus also sheds light on how climate change affects species distribution and adaptation. As environments shifted during the Jurassic, Allosaurus and its prey had to adapt or migrate. This phenomenon parallels current wildlife responses to global climate change, offering clues about how modern species might react to shifting ecosystems in the future. Research on Allosaurus, the fearsome predator that roamed North America during the late Jurassic period, provides valuable insights into the behavior and ecology of modern predators. By studying the fossilized remains and trace evidence of this ancient carnivore, scientists can draw parallels to contemporary predatory animals, enhancing our understanding of predator-prey relationships and hunting strategies. The skull structure of Allosaurus reveals a powerful bite force and sharp, serrated teeth, similar to those found in modern apex predators like big cats and crocodiles. This comparison allows researchers to infer hunting techniques and prey preferences, shedding light on the evolutionary adaptations that have persisted in predatory animals for millions of years. Allosaurus fossils also provide clues about pack hunting behavior, a trait observed in some modern predators such as wolves and lions. Evidence suggests that Allosaurus may have hunted in groups, tackling larger prey like sauropods. This cooperative strategy mirrors the social hunting behaviors seen in many present-day carnivores, offering insights into the development and advantages of pack dynamics. Furthermore, studying the locomotion and body structure of Allosaurus helps scientists understand the biomechanics of large predators. This knowledge can be applied to conservation efforts for modern endangered species, informing habitat requirements and prey availability needed to support apex predators in ecosystems today. Allosaurus, a fearsome predator from the late Jurassic period, continues to play a significant role in our understanding of biodiversity and evolution. This theropod dinosaur provides valuable insights into the ecological dynamics of prehistoric ecosystems, helping scientists draw comparisons with modern predator-prey relationships. By studying Allosaurus fossils, researchers can better comprehend the diversity of carnivorous dinosaurs and their adaptations. This knowledge contributes to our understanding of how different species filled various ecological niches, a concept that remains crucial in current biodiversity studies. The presence of Allosaurus in the fossil record also helps paleontologists reconstruct ancient food webs and understand the complex interactions between different species in prehistoric environments. Furthermore, Allosaurus serves as an important reference point for studying the evolution of large predatory dinosaurs. By comparing its features with those of other theropods, scientists can trace the development of certain traits and adaptations over time. This evolutionary perspective is essential for understanding how modern animals have come to possess their current characteristics and how they might continue to evolve in response to changing environments. The study of Allosaurus also contributes to our understanding of extinction events and their impact on biodiversity. By examining the factors that led to the decline and eventual disappearance of this species, researchers can gain insights into the processes that shape biodiversity over long periods. This knowledge is particularly relevant today as we face unprecedented rates of species loss and ecosystem changes due to human activities and climate change. Allosaurus, a fearsome predator from the late Jurassic period, has played a crucial role in advancing paleontological techniques. Studies of this iconic dinosaur have led to significant improvements in fossil preparation, analysis, and interpretation methods. One major contribution comes from the discovery of exceptionally well-preserved Allosaurus specimens. These fossils have allowed paleontologists to refine their techniques for extracting delicate bones from surrounding rock. The process of preparing Allosaurus fossils has led to the development of more precise tools and methods, which are now applied to a wide range of dinosaur specimens. Allosaurus research has also been instrumental in advancing our understanding of dinosaur biomechanics. By studying the structure of Allosaurus skulls and teeth, scientists have gained insights into how these predators hunted and fed. This has led to the development of sophisticated computer models that simulate dinosaur movement and behavior, a technique now widely used in paleontology. Furthermore, Allosaurus fossils have been at the forefront of applying new technologies to paleontology. Advanced imaging techniques, such as computed tomography scans, were first used extensively on Allosaurus specimens. These scans have revealed internal structures and features previously hidden from view, revolutionizing our understanding of dinosaur anatomy and evolution. The success of these techniques with Allosaurus has paved the way for their widespread adoption in studying other prehistoric creatures. Allosaurus, a fearsome predator from the late Jurassic period, offers valuable insights into climate change over vast timescales. This dinosaur lived approximately 150 million years ago, during a time when Earth's climate was significantly warmer than it is today. By studying Allosaurus fossils and the surrounding rock layers, scientists can piece together a picture of the ancient environment and how it changed over time. The distribution of Allosaurus fossils across different regions provides clues about temperature and rainfall patterns during the Jurassic. These fossils have been found in areas that were once lush, warm forests and floodplains, suggesting a climate much different from the present day in those locations. The plant fossils found alongside Allosaurus remains further support this view, indicating a world rich in vegetation that thrived in warm, humid conditions. Examining the bone structure and growth patterns of Allosaurus can also reveal information about seasonal changes and overall climate stability. Just as tree rings can indicate years of drought or abundance, the bones of Allosaurus show periods of faster and slower growth, potentially reflecting yearly climate fluctuations. This data, when compiled across numerous specimens, helps scientists understand long-term climate trends during the age of dinosaurs. By comparing the climate information gleaned from Allosaurus and its contemporaries to current conditions, researchers can better understand the scale and pace of climate change over millions of years. This long-term perspective is crucial for contextualizing modern climate change and its potential impacts on life on Earth. Studying Allosaurus, a large carnivorous dinosaur from the late Jurassic period, provides valuable insights into the biomechanics of modern animals, particularly large predators. By examining the fossilized remains of Allosaurus, scientists can reconstruct its skeletal structure, muscle attachments, and overall body plan, which offers clues about how it moved and hunted. The skull and jaw structure of Allosaurus reveal a powerful bite force and a unique feeding mechanism. Unlike some other large predatory dinosaurs, Allosaurus had a relatively weak bite, but could use its upper jaw like an axe, slicing into prey with its sharp teeth. This feeding strategy has parallels in some modern predators, helping researchers understand the evolution of different hunting techniques. Allosaurus also provides information about locomotion in large bipedal animals. Its leg bones and hip structure indicate how it balanced and moved, which can be compared to modern flightless birds like ostriches. This comparison helps scientists understand how body size affects movement and energy efficiency in both extinct and living species. Furthermore, studying Allosaurus alongside other dinosaurs and modern animals allows researchers to trace the evolution of certain biomechanical features. This evolutionary perspective enhances our understanding of why modern animals have developed specific anatomical traits and movement patterns, ultimately contributing to fields such as robotics and prosthetics design. Allosaurus, a fearsome predator from the late Jurassic period, has offered paleontologists valuable insights into the fossilization process. This large theropod dinosaur, whose name means different lizard, has left behind numerous well-preserved specimens that have allowed scientists to study how organic material transforms into stone over millions of years. One key insight from Allosaurus fossils is the importance of rapid burial in preserving fine details. Many Allosaurus specimens were quickly covered by sediment, protecting them from scavengers and environmental degradation. This rapid entombment has preserved not only bones, but also softer tissues like tendons and even skin impressions in some cases, providing a more complete picture of the animal's anatomy. Allosaurus fossils have also revealed the complex process of mineral replacement during fossilization. As the organic material of the dinosaur decomposed, minerals from the surrounding environment seeped into the remains, gradually replacing the original tissue. This process, known as permineralization, has allowed scientists to study the microscopic structure of Allosaurus bones, yielding information about the dinosaur's growth rates and physiology. Furthermore, the discovery of multiple Allosaurus specimens in different states of preservation has helped paleontologists understand the various factors that influence fossilization. These factors include the chemistry of the burial environment, the presence of certain bacteria, and the depth of burial. By comparing well-preserved Allosaurus fossils with more degraded specimens, researchers have gained a better understanding of the conditions necessary for exceptional fossil preservation. Allosaurus, a fearsome predator from the late Jurassic period, has played a significant role in shaping our understanding of dinosaur metabolism. This large theropod, with its blade-like teeth and powerful build, has provided paleontologists with valuable insights into the energy requirements and lifestyle of prehistoric carnivores. Studies of Allosaurus fossils have revealed features that suggest an active, warm-blooded metabolism similar to modern birds and mammals. The structure of its bones, particularly the presence of fibrolamellar bone tissue, indicates rapid growth rates that would require a high metabolic rate to sustain. This evidence has contributed to the broader theory that many dinosaurs, especially theropods, were endothermic, or at least maintained elevated body temperatures. Furthermore, analysis of Allosaurus hunting behavior and biomechanics supports the idea of an energetically demanding lifestyle. The predator's ability to pursue and take down large prey would have required substantial energy expenditure consistent with a high metabolic rate. This has led researchers to propose that Allosaurus and its relatives had metabolic adaptations that allowed for sustained activity and efficient hunting strategies. The implications of these findings extend beyond Allosaurus itself, influencing our perception of dinosaur physiology as a whole. By challenging the old notion of dinosaurs as slow, cold-blooded reptiles, Allosaurus has helped pave the way for a more dynamic and nuanced understanding of prehistoric ecosystems and the diverse metabolic strategies employed by different dinosaur groups. Allosaurus, a large carnivorous dinosaur from the late Jurassic period, plays a significant role in the ongoing debate about dinosaur metabolism. This fierce predator has become a focal point for researchers studying whether dinosaurs were endothermic, like modern mammals and birds, or ectothermic, like most modern reptiles. Evidence from Allosaurus fossils has provided valuable insights into this question. Growth rates observed in Allosaurus bones suggest a metabolism that was faster than that of modern reptiles, but not quite as high as that of modern mammals. This intermediate growth rate has led some scientists to propose that Allosaurus, and possibly other dinosaurs, had a unique metabolic strategy that combined aspects of both endothermy and ectothermy. Furthermore, studies of Allosaurus bone microstructure have revealed features typically associated with endothermic animals, such as fibrolamellar bone tissue. This type of bone structure is indicative of rapid growth and high metabolic rates, supporting the idea that Allosaurus may have been at least partially endothermic. The predatory lifestyle of Allosaurus also factors into this debate. Its role as an active hunter suggests it would have required a more constant body temperature and higher energy levels than a typical ectothermic animal. However, some researchers argue that even with a lower metabolism, the sheer size of Allosaurus could have allowed it to maintain a relatively stable body temperature through thermal inertia. The ongoing research on Allosaurus continues to shape our understanding of dinosaur physiology and the evolution of endothermy in prehistoric animals.